Balram sir, kindly stop the video so that we can start the session. Mr. Depinder. Hello, good evening, sir.
Yeah, hi, sir.
Good evening. Should we start, sir?
Yes, yes. Please don't call me, sir.
Okay,
Yeah,
Depinder.
thanks, thanks.
So, dear participants, I am Professor Vikram Sharma, coordinator of this online FTP, and it gives me immense pleasure to extend a warm welcome to all of you on the fifth day of this online FTP on AI for Atmanirbhar Bharat, empowering innovation, industry, and inclusive growth under the Atal program. As we move towards the concluding phase of this FTP, I must say that the past 4 days have been an inspiring journey of learning, interaction, and idea exchange. I am confident that today's sessions will continue this momentum and further deepen our understanding of the role of AI in driving innovation and inclusivity. We are privileged to have two distinguished speakers with us today. The first session will be delivered by Mr. Depinder Singh Nagi, Associate Director, Program Management, Fidelity Information Services, Chandigarh, on the topic data generation using modeling and simulation for machine learning. The second session will be led by Professor Dr. Prateek Bhatia, Associate Professor, School of Electrical Engineering and Computer Science, Washington State University, USA, on the topic a multi-model facial cue-based engagement detection system in e-learning context using deep learning. We are indeed delighted to have Mr. Depinder Singh Nagi with us for the first session. On behalf of the organization committee of this FTP, I extend a cordial welcome to you. It is truly a matter of pride to have you back with us as a distinguished alumnus of DAV College, Amritsar. We deeply appreciate your gracious acceptance of our invitation and your willingness to share your rich professional expertise with our FDP participants. I am sure today's discussion will offer valuable perspectives and practical insights, enriching the overall learning experience of for everyone present here. Now, I would like to invite my fellow colleague, Dr. Rama Sharma, the rapporteur of this session, to formally welcome and introduce our esteemed resource person. Over to you, Rama ma'am.
Thank you so much, sir. Myself, Dr. Rama Bhagwat, Associate Professor, serving as the rapporteur, along with our Technical Coordinator, Professor Balram Singh Yadav, for the 9th session of the day of the ongoing FTP on AI for Atmanirbhar Bharat, empowering innovations, industry, and inclusive growth. I welcome you all. It is my privilege to welcome our distinguished speaker of the day, Mr. Depinder Singh Nagi, for this session, data generation using modeling and simulation for machine learning. Mr. Depinder is an accomplished technology leader with over 20 years of progressive experience in software development, delivery management, and program leadership. His journey started as senior software engineer from NIT Technologies in the year 2009. He is currently serving as a senior development manager and release train engineer at Fidelity Information Services, where he has led several major digital transformation initiatives in digital retail payments, wire transfers, and infrastructure modernization. Mr. Nagi brings rich expertise in agile and DevOps practices, product strategy, and team leadership, having successfully implemented large-scale projects such as ISO 20022 Fedwire standards, a key milestone in the US payment industry. He has previously contributed to diverse domains, including e-commerce, banking, and aviation systems, collaborating with leading global clients like British Airways, Market Live, and Loyalty One Canada. Academically, he holds a postgraduate degree in Masters of Science in Computer Science from DAV College, Guru Nanak Dev University, Amritsar, and a BCA from Barkatullah University, Bhopal. Beyond his professional pursuits, Mr. Nagy is also an avid sports person, having captained his company's cricket team to multiple championships. We are delighted to have him with us today. Please join me in warmly welcoming Mr. Dipinder Singh Nagy. Over to you, sir, Mr. Dipinder ji.
Thank you so much, ma'am. Thank you, Vikram sir, from the warm welcome. I never expected this day will come because I was part of DAV college only, and I remember that our batch was the first MSc batch, and you, including Vikram sir, all were my teachers. So thank you for inviting me. Okay, so just wanted to know before we start. So, do we have students as well in the audience, or we have faculty members only?
So we are basically having a faculty and research scholars over here.
Okay,
So
all right.
they are widely distributed from all over India, in fact.
Okay, all right. Sure. Thank you, ma'am. I'll try to justify, the selection or invitation. So let me start. I'm just trying to share my screen. Just give me a second. Okay, is it visible, guys? Screen is visible?
Yes, sir, it's visible.
Okay, thank you, ma'am. Uh, so, uh, so today, basically, we are going to touch the part of AI which is called machine learning. We'll talk about models or modeling. We'll talk about simulation and data generation. So, data generation is basically, the main part. It acts as a fuel for artificial intelligence or machine learning. So, it is very important, right? So, before we start with the artificial intelligence, so we need to know like what is intelligence. So it is very important, to understand what an intelligent system can do and what a normal, traditional system can do. So if we see the slide, so the ability to, acquire and apply knowledge is basically intelligence. We have, a lot of systems in place which we consider as intelligent systems, but they are not actually. They are just, doing whatever instructions we are passing to do, but there are no systems in place before this AI comes which can act on their own. So basically, the this ability to learn or understand, and by learning those things, we are discovering new things, we are adding new data sets or new challenges, and overcoming those challenges. So basically that is part of intelligence. uh, I have written one thing like cognitive complexity. So cognitive complexity, what is this is when we are given with certain requirements or different challenges, how we behave when the variable changes. A very simple example could be when we catch a ball, uh, when we catch a football, our strategy will be different. We know the speed and time with which the ball will come to us. But when we are going to catch a cricket leather ball or a season ball, our strategy will be different. So adjusting accordingly, according to the different situation. So that is called, sorry. Okay, that is called cognitive complexity. So if we see example of an intelligent system, there are five main areas. So basically, we need to have an agent. We need to have environment, where the system will work. we need to have a goal. Without goal, no intelligent system can work. Most of the intelligent system, they won't work. Then we need to have a perception, like how we are, going to achieve our goal. And then finally, the action which we need to take. If you see here, basically three examples we have given, like a human, a mouse, and ant, right? So mouse example is basically mouse need to catch a piece of cheese inside a maze, right? And in human, basically we need to pass an exam. For ants, they need to protect their colony from attacks, right? So here, human, mouse, or ant, who are going to act, they will be, called as agents. The environment, examination hall would be an environment for a human. Maze would be, environment for a mouse, and colony will be environment for ants. The goal, human's goal is, to pass the examination, right? And cheese is the ultimate goal of the mouse. And ants, they have to protect their colonies, right? So basically, these are, the common factors, that we must have an agent, and we must have a goal. We must have an environment. Environment may not be required in, some of the cases, but in most of the cases, environment is required. And finally, the action which we take. So if we conclude, the definition is basically ability of an agent to, perceive an environment, run time dynamically, and to choose actions that increase its ability or, chances of achieving that goal, is known as artificial intelligence. Just a second. Okay. Going further. And now, what is artificial intelligence? We understand, we understood intelligence in terms of humans, right? But if we talk about the machines, so artificial intelligence is the same ability of a machine, to learn, understand, grasp, and implement the things. Obviously, expected likelihood would be, that it is going to achieve a goal. Here, agent is a machine of some kind. It could be a hardware, it could be a software machine, it could be any machine which is made by humans. Just a second. Okay. So my screen is visible, guys. Can anyone confirm?
Yes, yes.
Okay. All right.
Yes, sir, it is.
Okay. All right. Thank you. Okay. So basically, we are agents. We agents are, the machines. They replace humans. And a robot could be an agent. A software could be an agent. Most recent example which we are using a lot these days is a Roomba machine. Roomba is a, cleaning device which clean or mops, the floor on its own. So we are going to talk, a lot about that Roomba machine as an example, in many of the cases, right? So this is basically a simple definition of artificial intelligence: ability of machines, to do that work which we are expected, to use an intelligence. Now, if we talk about intelligence, so this artificial intelligence journey, has been started since long time, in 1960s or 60s, 65s. So we, tried a lot of things, data related AI, then knowledge based AI. So it is not a new thing. So the data has been, collected since long time, since decades, right? So if we generalize the artificial intelligence, so there are two kind of artificial intelligence. Basically, there are three, but two are, we are still working on that. So first is artificial narrow intelligence, which is called ANI, and second is artificial general intelligence. So if we talk about the narrow intelligence, so this is what it is in practice, these days. It refers to the AI systems which are specialized to perform a single task or a narrow task. For example, a specific task. Let's say we do a lot of work with Siri or Alexa, right? We ask Siri to call somebody, or we ask Siri, to set up an alarm. So that is a kind of, narrow intelligence system. Then we have spam filters in Gmail, or any of the emails. We have, different filters in place where we can, define our own rules. For example, if I get a mail from Amazon, that it could be, treated as a filter. So that is my direction to the system. That is a narrow system. So now the question can come into the mind that put an alarm for me, and then it can read message for me. But those are sequential. That is not multi-threaded. If we talk about in IT language, so there is a single task and then there are multitasks. So this is, focusing on one particular area, one particular domain, or, one particular instance. So that is called ANI. So all the systems, for example, let's say, our self-driving cars. So they are also, part of narrow intelligence systems only. Why they are narrow intelligence systems? I'll give you an example. Uh, let's say we are, driving a Tesla, right? And we have set up a route over there, like from my office to my home. So, the ultimate goal of the my machine would be, that it needs to take me my home, right? It may take 30 minutes, it may take 40 minutes, or due to some a road blockage, or let's say there is a flood situation, it is showing me now that it is going to take 12 hours. So now it will stick to its goal. It is not going to take another decision that, okay, the area is blocked, or there are floods, you need to go somewhere else. Unless until I am going to tell that system that, okay, let's do something else, it is not going to change the direction. So that is example. Then we have Netflix. I think everybody is using Netflix these days, right? So you must have noticed, even in YouTube also, once you started looking some science fiction movies. So every time you log in, it will give you a lot of suggestions that, okay, these are the new science fiction, or these are the recommendations for you, right? So that is part of our narrow systems. Okay, the key characteristics here are, these are task specific. It cannot generalize or transfer learning to the unrelated task. For example, a car will only drive car, right? It is not going to protect you from something else, or it is not going to do something which is not described or programmed into, right? No self awareness or consciousness. It is a simple thing. And mostly all the systems which we are using are narrow systems. Then we have AGI also, which is artificial general intelligence. And there is another mode of intelligence which is maybe supernatural thing, which is called artificial super intelligence. If you see the differences in all the stages, so right now we are achieving at ANI, and AGI, the things are still happening. We are expecting a lot of things, just as I have given example that the car will take a decision on its own. Let's say different example. I am going to visit an office which close at 7 p.m., right? And around 6 p.m. I leave from my home, and I set a map on my car that, okay, take me, it's a self drive car, that, okay, take me to that particular office. Now there is a blockage, or curfew situation, or there is a lot of traffic, and now the system will is showing that it is going to take another 1 hour. So which can be 7:30. Now the car is not that intelligent, that it can take a decision that, okay, 7 o'clock that office is closing, so let's not go there, right? So that kind of thing are expected in artificial general intelligence. ASI is a very very futuristic thing. We are still working on that. So if you see the type, so ANI is narrow or a single task based. AGI is generic, or general or human level, where we can do multitasking. In IT language, you all are IT people, so it could be multi-threading kind of thing. Scope of intelligence. ANI is specific domain only. We have super intelligent systems in ANI. For example, robots who can do operations, right? They can do heart surgeries. But if you ask that robot to make a cup of tea, it will not be able to do that. Why? Because it is only specific to that healthcare domain, right? Or I mean, specific domain, whatever domains we can assume. In AGI, the multiple domain understanding would be there. For example, the fictitious robots we are talking about. Uh, Everybody must be, must have watched that movie Avengers, where that Iron Man has a system called Jarvis, right? So Jarvis do a lot of things for Iron Man. So I think all kind of things he's capable of doing that. So that is a kind of super intelligent system, or the general system. Risk level, if we talk about, then it is low in ANI and moderate in AGI, and we don't know yet like what ASI can do. So why we are talking about risk is because we must have seen movies like Terminator, or even Avengers. We have some villains which are programmed, right? So if those machines, they started taking decisions, they have emotions, like if you abuse them, they can go on a bad side. So that is going to be a risk. So why ANI is on low side? Because it is going to do only a specific set of tasks which are fed into that system. They have no conscious, they have no emotions, so they will not do anything bad. They can do bad if we ask them to do bad, right? Okay, examples, Google Maps are part of ANI, Netflix recommendations, and for AGI and ASI they are still in experiments. Okay, so these are the simple basics, like, which I think we should know, because we will talk a lot about these basic things. Okay, now introduction to machine learning. So now we know what is intelligence, what is artificial intelligence. Now machine learning is way to teach computer to learn from experience. When we say experience, that is intelligence, right? Just like humans, instead of being told exactly what to do, they need to figure at their own. Let's say we we need a system that can any example I can give. Okay, that can do multiple calculations, right? So what I can do is I need to uh, feed a lot of mathematical data into it, and I can give maybe 100 or 500 or 1000 examples. Okay, how to do this calculation, how to do that calculation. But ultimately the goal which I am having is to process millions of transactions, right? So it is not possible that I fed in millions of transactions and then expect the same kind of result. I may be feeding 1500, 2000, 500, or maybe 50,000 data sets. Now with that data, that machine, by using its knowledge or its artificial intelligence, it is going to make a relationship between the different variables. And then with unseen data or unknown data, the new data which I am going to fed, it is going to give us the expected or desired results, right? So in simple language, it is a subset of artificial intelligence that focus on developing algorithms and statistical models that enables system to automatically learn and improve from data without explicitly programming into that, right? We'll come to that. If we see the diagram here, it says we fed data into the application. Application is any model, and sorry, application, it is an algorithm, right? So majority of the things in artificial intelligence is done by the algorithms. You can consider that algorithms are the brain of the artificial intelligence or machine learning or this era, right? And here algorithms are not simple algorithms like if else, if A then apple, then if B then boy. So they are designed to relate the data, create the mappings, and go to the desired outputs. Okay, so as I told that we fed a lot of data, because without data no system can be intelligent. We have to tell something, right? We need to teach at least alphabets to a kid, and then that kid can start making the words or sentences, right? So those sentences can the words are basically the foundation for that, right? Okay. Now there are basically when we talk about learning, so there are three kind of learnings. One is supervised learning, one is unsupervised learning, and another is reinforcement learning. So these learnings are to identify, define, make predictions, or define the patterns. Now when we talk about supervised learning, supervised is something we teach someone, right? Just like teachers do that with our students, right? They tell them like about a topic, and they'll they go into details. So whatever we are going to fed, so those things they are going to learn, right? This is a simple, we are going to details for supervised learning also. Then we have unsupervised learning. Unsupervised learning is we are giving raw data to the machine, but there are no relationships, right? uh, the machine should be using some algorithms which can decide at its own that what is the relationship between these two data. I'll give a very simple example. Let's say there are 100 people uh, in a room, right? And everybody have a play card in their hand. It says, or okay, not a play card. So let's say 25 of them, they are wearing red color t-shirts. 25 having green, and rest 50 are having blue color of t-shirts. So they are categorized. We know these are red team, and this is a blue team, or this is a green team. But let's say they have different colors. There are no labels, or there are no attributes defined for them, only names. So what an unsupervised learning or supervised system that should behave is like, it should make the relationship between all the people. For example, it identifies that there are 15 people who are longer than others, right? They are having 6 feet or above. Then it notices that okay, there are 25 girls or ladies or females, right? And then it identifies that there are 15 people who are not interacting with anyone. So instead of we giving them labels that okay, that guy is an engineer or he's a doctor, so that system makes its own predictions, and he says that okay, these 15 are the longest people, these are 25, these are ladies group, right? Or they are the less interactive people. So this is kind of example. We'll go into details. And then there is reinforcement learning. As the name suggests, reinforcement, the system is enforced to learn something by its own, by hit and trial methods. uh, for example, when we speak about this Roomba device, which clean at its own. So it is a common device, right? We don't design it for a particular home, a 3 bedroom home or a 2 bedroom home, or a simple room without a furniture. It is supposed to work everywhere, right? There may be sofas in the room, there may be tables in the room. So in reinforcement learning, that agent or that device, it learns on its own. When we start it for the first time, so it start rotating here and there. It will create a map, and it will learn by its actions. Let's say it goes straight and it hits with an object. Then he knows that okay, if I go into the north direction, there is an object. Then it will come back to its original position, then it will take another action. So that is how it scans the whole system, and eventually it gets better at that. Okay, now we okay, yeah, before we go to supervised learning or unsupervised learning, we need to understand what data set is. We talk a lot about data or data sets. So whenever I will say that data, so it will be a data set, right? So in AI, data sets are into two categories: either it is labeled or it is not labeled. When we say labeled, so that is always a supervised kind of learning, where I am telling everything that okay, this is a cat, or this is a dog, this is a boy, this is a girl, right? In computer programming, we use annotations, right? So we can consider that these labels are annotations only, right? Okay, so label data used in supervised learning has some pre-assigned tags or labels, which guides our model to learn some specific patterns and make accurate predictions. Like I've been telling that okay, this is a particular dog, or this is a particular dog, this is a particular cat. If the color is red, the answer should be positive. Or the if in case of traffic lights, if the color is red, you should stop. If the color is green, you should go. Yellow means you have to wait. These are tags, right? Red means stop, green means go. So these are predefined, or we can say these are hard coded kind of things. Like the relationship or the mapping is already there. For example, the simple example could be, let's say if the person is getting 40, minimum 40 marks. I still assume that it is still 40. That is the passing marks, right? It is 40 or above, it is pass, right? And it is less than 40, it is fail, right? So so label data, where each input is associated with the corresponding output or a target label, right? And purpose is that model, they need to learn to map the inputs with the outputs, right? We'll give more examples, then we will understand. Okay, here the examples are like image dataset with labels indicating objects, example cats or dogs. Okay, when I say data, that means data set. So it will not be, simple variable that image and then cat, right? Along with the image, there will be, hundreds of parameters. For example, the image will be of cat, then it is parameter or characteristics will be, it has two eyes, it has one tail, it has, pointed ears. So similarly, there are a lot of parameters inside. And the complete set of that, those parameters are called data sets. Data will never be, one liner of data. One line of data would always be called as instant or instance, right? So we need to have complete data set. Okay, the applications of these are, classification and regression. We'll come to regression and classification also. So basically, there are two kind of applications, classified and regressive. So in case of classification, it is always a classified kind of information. For example, either it is A or it is B, right? Either it is a digit or it is a numeric, or maybe, something else, maybe a figure, right? So these are defined. Classified, like true, false. These are classified, right? Or classification. In regression, these are always, deal with the numerical things. And these both areas, they come under the label data, right? Or the supervised learning. Okay, the characteristics of these are it requires human effort or automated labeling tools to create labels, which can be time consuming and costly. This is we don't need to worry about that because we have a lot of tools we can which can generate a lot of data now. Okay, then we have unlabeled data. Unlabeled data where input is not associated with anything, any corresponding output or targeted label. It is majorly used for unsupervised learning, where we expect system should create the patterns itself or mapping by itself by learning new things. Okay, where model discover hidden patterns and structure in the data without predefined labels. Example could be a large collection of images, text or audio without any specific annotation. Customer transaction data, like my expertise is in basically banking and payments, right? So normally on daily basis we get millions of records. So we only got records which says that okay, this transaction has happened, which bank, how much payment has been done. So these are not categorized, although this is not maybe a very good example, but this is one of the simple examples. Or maybe another simple example of unlabeled data is let's say we have a voice message, right? And we don't know what voice message it is. Let's say it says that um, let's say we ordered something from a shopping mart and we got the delivery, and as a feedback the message we send is the delivery is late but the product is good, right? Now it is not saying anything, it is not coming into any of the category, right? But if we break it down, because unlabeled data we always have to break it down to a meaningful data set, right? That is the job of machine learning. So it will it will divide that sentence into different words, like it will say is product, it will relate it with good, that okay, product is good, right? And then it will say the delivery is bad. So as a feedback we need to work on delivery part more. So that is the meaningful data which we translate. Similarly, there are thousands or millions of records where we need to do this exercise. Okay. So application of unlabeled data are basically clustering. Clustering is the type of unlabeled or unsupervised learning where we group similar kind of things. For example, grouping similar customers. Similar customers means those customer, let's say, who also use the postpaid plan and they take broadband also along with them. And there are customers who may have postpaid, they have, or they don't have, or they have broadband connections, right? So we'll come to clustering as well. So so the characteristics are like they are abundant in natural or human made sources but require exploration and analysis to extract valuable insights. As I gave example of that audio clip, that okay, the product is good but delivery is bad. So we need to make need to extract the information out of that, right? Okay, some sources of data sets. I'll maybe come to this part at the end of the session. These are some sources where we can get ready-made data sets. We'll come to that. Okay. Now we come to the supervised learning in a little bit detail. So supervised learning is a machine learning method in which algorithm is trained on a labeled data set, right? Predefined data set. The algorithm is given input data and the corresponding output, correct output, what we are expecting. And it learned to find the relationship between them. The relationship basically is then used to predict the output for new or unseen data, right? Example, let's say, we need to create a spam filter for our emails, right? So what would be the input for, that machine? I'm not talking about, the ready-made spam filter, which is available in Google, but how, we can create our own spam filters. So if we see the example here, the inputs are words in the email, in the context of that email or in the subject line of that email, or, who is the sender. For example, let's say I don't want, emails from the social marketing. So whatever emails are coming from Facebook, they should be, spam for me, right? Or if there any keyword like promotion or sale in the description or in the subject of that email, so that could be a spam for me. What are outputs? A spam or not a spam? There are only two outputs in this case, right? Okay, how it works? So supervised learning operates similar to a teacher instructing the student. The breakdown is basically, we need a lot of data, labeled data collection. We get that data, we tag that data with the the correct answer, and then we trained our model. We fed that data into the model by using our algorithms, right? The algorithm is fed the training label data and adjusts its internal parameters to learn from mapping from input to output. It continuously checks its predictions against the correct labels and adjusts to reduce error. It is a iterative kind of thing, right? So let's say we we fed 1000 records of some kind of processing. So when that simulation runs or that algorithm is fed that data, so it knows the relationship between these two, right? uh, and then the unseen data will be tried on that. For example, let's say we create a machine that differentiate between apples or bananas, right? So now the data which we has given is that okay, apple is round, and the weight of apple is certain. Banana is longer, it's not a round kind of thing, right? So we have given these kind of data, but let's say we have given him a bigger apple or bigger banana. So still by its length or breadth or its circumference, it is still able to understand, okay, this one is a rotten or maybe smaller banana or maybe a bigger apple, right? It is still going to give us the predicted output. Then we train that model. The algorithm is fed the label training data and adjusts its internal parameters and learn from mapping. Then we evaluate the model. We do a lot of hit and trial. We do UAT. UAT is basically user acceptance testing, right? With a lot of unseen data to evaluate its performance and ensure that it is doing what it is intended to do. And then we basically once the model is fine, the performance is satisfactory, so it can be deployed to make the prediction on new data. Okay. So guys, please be interactive. It would be very, very helpful for me also if you ask questions or if you have any doubts. So, right. Okay. So now we learned about this supervised data. Now we are going to learn about this supervised learning. So initially we told that there are two kind of supervised learnings, which are classification and regression. So as discussed, so classification is when we make a decision or prediction involving two or more categories or outcomes, right? For example, in email filtering system, it is a spam or not a spam. In medical diagnosis, let's say the machine is taking blood sample, so either it will come with disease A or not a disease, like it is a healthy person, or maybe B disease. there could be 15 diseases, right? So A, B, C, or maybe healthy, right? Now sentimental analysis, it is a positive, negative, like before election, the kind of survey they do. So, how is Congress doing? Okay, positive or negative, right? Then loan applications. So these are all, examples of supervised learning. So we'll see these in supervised learning models. So based upon your credit history, it says that okay, your balance is good, your previous credit card payments are done on time, so your loan application is approved or rejected. Then we come to regression. So regression, as I told earlier, that it is basically related to outcome based upon the numeric calculations. So here the algorithm find the relationship between input variables and a continuous output, right? The examples are like house price predictions. The answer, or the predicted value would be in dollars or INR. Weather forecasting, it is a temperature numeric value again in Celsius or Fahrenheit. Stock price, sales forecasting, age estimations. So these are all part of regression. Now we look about this unsupervised learning a bit. So it's a type of machine learning that analyze and cluster unlabeled data, right, without human supervision. It is basically a raw data set. Machine needs to make all the patterns, right? Okay. Yeah, so model is given input data without any output. A supervised model is given only, unsupervised, only given a raw data. And it must create, its own rule and structure based upon similarities or differences or patterns. Just like, we mentioned that, okay, there are, some people who are longer than others, some people who are shorter than others, right? So how it works, almost, the same thing. It collects unlabeled data, it selects an algorithm, train the model, and interpret the results. So before, these two parts, before, after, collecting the data and selecting the algorithm, it do a lot of things in between. Like, it makes sense. It make sure that, the data makes sense. It, connect the dots and define the patterns or define the rule sets. Right? Will come to that. Okay. So examples of these are, suppose we have large set of customer data, age, spending habits, and location, but no categories like it's a loyal customer or no. So unsupervised, algorithm can come to a conclusion that okay, this particular person spends a lot, or this particular person spends only during Diwali and Christmas, when we have a lot of sales going on, right? So behavior, similar behavior patterns, like helping to discover natural segments, frequently high spenders, discount shoppers, or inactive users, etc., etc., right? Okay, so now we come to unsupervised learning. So in unsupervised learning, we have four different kind of learnings, or subparts. One is clustering, which is the most common form of the unsupervised learning. Basically, here we group the things together. For example, customer segment, or let's say we type something in Google that some news is going on, that something happened. Let's say some incident happened. As soon as we type into the search box, it give us a lot of records, lot of news articles. Let's say two articles from Times of India, one article from Hindustan Times, but it is going to give us the similar kind of things, right? So the clustering is the most common form. It is used to group similar data point together. It identify natural grouping or cluster within the data. Excuse me. Example of clustering: customer segmentation, like their similar purchasing behaviors and prefer that helps companies to target the market, market campaigning. Then news article categorization. Then there are lot of research happening in genetic world, in biology basically. So they pattern, they analyze the DNA patterns to reveal more basically innovative ideas or new inventions. So there are specific algorithms already created for all these kind of learnings: supervised learning or unsupervised learning or reinforcement learning. So here are few examples, like K means, which is a centroid based clustering. It works like looking at the nearest data point, since it is a cluster kind of thing. So it is, looking for similar data points. Hierarchical clustering, it is also same, but instead of uh, collecting the data, it is, representing the data in a hierarchical manner, right? So we have density based clustering. Again, density says us that, where the population is more dense. So that is one kind of area, right? DB scan, distribution based clustering. So all these are part of, unsupervised clustering techniques. Excuse me. Now we have, dimensionality reduction. So this technique, is used to reduce the number of features of variables, right, in a data set. Let's say, I'll give you a very practical example. We must be using iPhones, right? And in iPhones, we since it is, expensive device, so we and I think the higher version of iPhones, which with like 1 TB memory or 512 gig models, they are expensive, right? So what we normally do is we take, Google, oh sorry, not Google, but cloud space, right? iCloud. Similarly, Google Cloud is also there. So have you ever noticed that, let's say your memory of your phone is full, right? And you upload your data to that iCloud or, Apple Cloud. So if you see, one gigabyte of photographs or pictures, when they got uploaded into that iCloud, the size would be 250 MB. So they compress those, pictures. And the interesting part is, when those pictures are downloaded again from that iCloud to your iPhone, right? The resolution is same and the size is also same, right? So this is one of the examples of dimensionality reduction. So these techniques are used to reduce the number of features or variables in a data set while retaining most of the important information. This is used for dealing with the high dimensional data, which can be computationally expensive and difficult to visualize. So the different examples of it are principal component analysis, right? It is a technique that transforms the data set into a new, smaller set of principal components. For example, let's say I need to know a detail of a person, right? Uh, but there could be, a lot of details, like hundred of variables can be their name, age, schooling, first address, second address, third address. So what I do is I, reduce that data set. I will take only relevant information from that. For example, I don't need to know what are, that person's KG class, friends, or nursery teacher. I don't need to, know that name. So I'll reduce whatever data. uh, that data could be, in form of text. In case of image also, well, while, I'll change the resolution of that image. It could be noise also. For example, you must have seen that, sometimes we in cyber securities or in cyber crimes, we have a clip of audio, right, where there is a lot of noise is also coming along with, the conversation. So using these techniques, we reduce that noise, we remove that noise component, and then, we come to the actual thing. So these are part of, PC or principal component analysis. So these are the few algorithms which I have mentioned. TSNE, like T distributed scholastic neighbor embedding. It will go, to the nearest neighbor or the nearest data point, right? And see if that data point is required or not. So similarly, we have LDA, linear discriminant analysis, UMAP, uniform manifold approximation and projection. So these are example of dimensionally reduction, unsupervised learning. Okay, now there are two more types: association rule mining. Okay, so the word association is, a kind of self-explanatory itself. It finds the associations between, the data. Uh, with example, it will be clear. Let's say, market basket analysis, or basically recommendation engines. For example, if you go to Amazon, so you buy a product, right? Or you select a product. You have not bought it yet. You are looking at the, description, or, the features, or whatever details, right? So in the below section, you will be noticing that, there is a prompt telling you that, the customers who bought this item has also bought, similar item. For example, if I am buying an iPhone, so it recommend me that, okay, you are buying an iPhone. The most of the customers who are buying an iPhone, they are also, going for the AirPods also, right? Or the any similar Apple device, right? So these are the kind of example of associate rule mining. So it looks at the patterns or behavior which are similar in nature. For example, uh, yeah, same example which I have given. Like platforms like Amazon use association rules to power features like, customer who bought this item also bought this. For example, I was uh, purchasing a vacuum bag. So they recommended, the vacuum bag, mostly, the users who are purchasing, they're also purchasing a vacuum pump also, so that, we don't have to manually vacuum that, right? So the pump is also there. So when we collect that kind of data, so that comes under association rule mining. So similarly, there are a few algorithms which are being used a priori. This is the most frequent one. It finds frequent item sets, FP growth, frequent pattern growth, equivalent class transformation. So these are, the algorithms. Then we have anomaly detection. So anomaly detection is, unlike association rule mining, it looks for something which is, different in nature. It involves, identifying unusual data which deviate from the rest of the data set, or which do not fit in the normal behavior. For example, fraud detection or in cyber security. Let's say since, in payment domain there are a lot of checks in place. So there is a, check which detects the fraud. Right? It sees the behavior of a customer. For example, I know that, this particular customer never spends, more than $10 or $15 or $20 in a credit card, right? And that too in the, first half of the month. Maybe after, second half, he stopped, spending its credit card, right? Or a debit card, whatever. So suddenly, my system detects, or my algorithm detects that, there is a purchase of $500, on maybe 25th of a particular month. So immediately, it raise an alert that anomaly has been detected, right? Because the pattern of that user historical data never used to do that. So either it can, stop that payment or raise an alert. That depends upon, bank to bank, or it is a basically rule based thing. But this is, a classic example of that. In cyber security, let's say you are running a website, which is a user based website where, user has to provide credentials also. It's not like, a guest user is there, right? So you must have been dealing with the millions of customers on daily basis, since, we are global now. So suddenly somebody entering his password and, the password is wrong. So that is an anomaly, because out of maybe 1 million data sets, only 5 or 6 customers which are not, using their actual, they are kind of fraudster, or, that could be a attack on your website. So that anomalies, can be detected by these algorithms. Other is healthcare department, where, these algorithms has been used heavily. Let's say uh, we take, blood samples of a lot of people, and mostly are healthy, but there are unusual patients whose symptoms are different, right? Where we need more research. So these are kind of things. So there is a algorithm called isolation forest, and then local outlier. These are some kind of algorithms which are used. Autoencoder is also there. We can, look at the details on the net. Okay. Now we come to the third kind of, learning, which is reinforcement learning. So earlier learnings were, clearly categorized into supervised or unsupervised, but this reinforcement is basically, uh, can be categorized into both. It can be fitted into, supervised learning models also, and unsupervised learning models also. So here in reinforcement learning, it is a subfield of ML that focus on how intelligent an agent can be, by hit and trial methods. So if we see the definition, so agent can learn optimal behavior by interacting with its environment. The first example we gave on the first slide, where there was an agent, there was an environment, then there was perception, action, or a goal, right? So that is the part of or example of reinforcement learning. Here, the agent learns through a process of trial and error, receiving feedback in form of rewards for good actions, penalties for the bad actions. The core components would be that Roomba thing, Roomba thing is the classic example. Uh, let's say that Roomba or that, cleaning machine, we start that machine. The goal is, to clean the floor. The first action it may take, go to the left side. After going to the left side, it sees that there is no obstacle, and it cleans the floor. So that is a reward kind of thing. It comes back again, it again move into the different direction, and it notes eventually, it do lot of iterations, and maybe in 5 days, 10 days, 15 days, it draws a map of uh, your floor, or your home, uh, and it knows exactly where the sofa is, where the bed is, where the chairs are. And ultimately it will be trained so much that without any break, or hitting any obstacle, it is going to clean the floor, right? So the core component are very simple and very straightforward. There is an agent, there is an environment, state, action, reward signal, policy, and value function. Here in this case, agent is that device, a software program or a robot. But in our case, it is a that Roomba device. Environment is the basically the room where it is supposed to do that all cleaning, right? State, the current state is its current location. So with every move it makes, its state will be changing, and then it is going to take another decision that, okay, have my goal have been achieved or not. The goal is to clean the floor. The reward is basically the floor is cleaned, or it has not hit any obstacle, and it has added a new dimension, or a new location in its the map which is it is creating. Reward signal is positive or negative, as I told. The policy, simple policy, is that what action it needs to take, like the strategy that needs to take. For example, he knows that 50 meters left from where the docking station is, there is a wall, so it will never go beyond that 50 meters, right? Value functions, the predictions, ultimately it draws the map into its memory or cache, right? And it knows like where the things are happening. So where a model and environment are involved, so that is called reinforcement learning. Okay, how it works? We know the steps, but how it works? By observing the state. I think it is straightforward. We don't need to go that. But simple, the working workflow is basically observe a lot of things, then it take actions based upon those observations, rewards, and the new state. Rewards are basically achieving something, it's a reward signal, and penalty is basically hitting an obstruction, right? Then updates, how it updates, how it perceive the environment. Iterations, it has to be continuous kind of thing. So another examples of reinforcement learning are like games, playing AI, robotics, autonomous, these vehicles, self-driving cars, Tesla. Eventually, they get better. Uh, let's say they are trained in US, or other foreign countries where they have similar kind of traffics on the road. For example, in US, on roads we mostly see cars. But if that Tesla, self-driving car comes to India, just imagine, cycle is coming from one side, then auto rickshaw is coming into from another side, then there may be some animals also, right? So that system needs lot of training, and eventually maybe one day it get trained to work on that road conditions also, right? Resource management. So when we say resource management, then it is basically the data centers kind of things, where because data centers are very costly affairs. So let's say we need to cool down, we need to lower the power consumption on some different times of the day. During the peak day hours, it is very hot, so the AC temperature needs to be more means it needs to be more chill. right? So these kind of things are part of that. That algorithmic trading is one of the um, one of the typical examples where we have indicators in our demat accounts, right? If you know about indicators, so they tell you real time that okay, the stock is going to be on a higher side or lower side, or it recommends that whether to buy it, hold it, or sell it, right? And then again, the personal recommendations, for example, that Netflix and Amazon example. Common algorithms used here are q learning, sharsa, reinforce, trpo, ppo, a to c. A lot of examples are there. Any questions? I hope everybody is still here.
Yes, actually, the question answer session round will be after your
Okay.
deliberation.
Okay, all right,
So,
sure.
otherwise, there are 2 questions in the chat box.
Oh, I have not seen that. Okay.
Okay, it's okay. I will be discussing that after the things are
Sure.
delivered.
Okay. Okay, now we now we know the kind of learning, supervised learning or unsupervised learning. Now we come to the modeling part. So what are models? So models are the structures or the compositions which we create as testing efforts, right, before we jump on to creating a real kind of thing. And sorry, similarly, the machine learning models are the programs that learn patterns from data to make predictions or decision on new data without being programmed for each and every scenarios. We create model for something, we fed some data into that, we choose a related or particular algorithm which is relevant to that particular problem statement we have, and then we fed that model with lot of data, new data, then using the data which that model has not seen yet, it already has the relationships created, so it predict the new relationships and start giving the outputs. So the modeling process in machine learning is the complete life cycle of developing, training, and deploying a machine learning model, right? It is same like our SDLC or software development life cycle. The components are like problem understanding, data preparation, and the feature engineering, model selection, model evaluation, and testing. So these are the major part. The major is the data which we fed into that. Okay, so let's discuss these one by one. Problem understanding and data collection. This is a clear thing. Like we need to know the goal, before creating any problem statement, right? Or we need to know why we need a particular model. Data sourcing, get sufficient data from database, APIs, internet, or create your own data, or create that lot of synthetic data. We'll come to synthetic data as well. After we understand the problem and data is collected, data preparation and feature engineering. So now we say that we have collected the data, but again the data preparation part is there, right? And feature engineering, this is a very important step in case of a modeling process. So when we say data preparation, that means data profiling. Now data profiling means we have to make sure that data is very good in terms of a lot of different things, like data cleaning. It handles missing values, it remove duplicate values, it remove inconsistent values. There might be special characters in some of the files. For example, the real life example is that when we do payments, there are some real time payments, just like we have different modes. One is something which happen real time, and then there are batch processings which are happening. So a lot of banks, they don't in US basically, still the real time payment is not adapted by all the banks. So what happens at end of the day, they send us huge files to process. And mostly when when we have huge files, let's say millions of data, so if one record has a corrupted data, let's say underscore sign or some special character, or some data is missing, the whole batch fails. So before processing that batch, data profiling is happening or data cleaning is happening, right? So which is a very important step because the data which being fed into these machines or these model or these simulators are huge, immense data, millions and millions, right? So data cleaning is a very important part. Then feature engineering, create new features or transform the existing ones to improve models performance. Okay. It can also involve encoding a categorical variable, scaling numerical data, or extracting new features. Let's say the Roomba device which we made. We have made a model. It has being it's being selling. It is being hit also. But there are new things which we need. For example, it don't work on night. Its sensors are not uh, that good or that accurate that when there is a dim light, so it start behaving in a different manner. So maybe the Roomba 2 will be coming, and when we are preparing data or we are doing feature engineering, then we know that okay, these were the outcomes. So we might have to provide more features, right? New features. We need to improve the cameras, or we need to improve the scans, or maybe we need to add more section capabilities into that device. So feature engineering, that part where we modified the existing features or create the new features according to our problem statement. Then data splitting. Yeah. So then since there is a lot of data, we need to make sure that we need different scenarios to train the data. We need different scenarios to validate the data. And maybe for testing or UAT, we need a different kind of data, actual data, right? So we split data into different forms. Okay. Then model selection and training. Obviously, that is the most important part. When I say model selection, so that means algorithm selection. There are different algorithms for almost everything. Binary search, or image reduction, or anomaly detection. So lot of work has been done. So you can create your own algorithms also if you have time and capabilities, definitely. Otherwise these are readily available, so we need to choose okay which algorithm will serve our purpose. And then hyperparameter tuning. Okay. So hyperparameter tuning is basically the data which is not maybe related to your problem statement, but maybe related to your actual model. For example, a very basic example could be in Oracle. There is a I think aura.config or config.aura file, right? So that is example of a hyperparameter. So in that config.aura, we give certain parameters which might not be related to your organization, right? The data, but it relates to the actual model, which is Oracle, right? In that case, so it helps improving that model. Like I'm going to increase the cache value, or in connection pooling. Basically, let's say the example of a application server, right? I changed the number of connections to be available, more than what there are actually in default, right? So these hyperparameters are the parameters which optimize the model. They might or might not has to do anything with your data, actual data, or the problem statement. Then model evaluation and testing, and then model deployment. So in model evaluation and testing, basically we use a lot of metrics. So for any data or any event, or any function, we use a lot of matrices. So matrices are nothing but the uh, sorry nothing but the formulation, or the capabilities where we access or assess that the system is doing good or not. For example, attendance is one of the metrics, right? Another common example of a good metrics maybe we are in agile world, and in actual development we we plan for 3 or 4 months of work before we even attempt that. So when we plan that work, so there is a metrics called feature delivery predictability, that okay whatever features we are picking, that okay we need to create 5 new features, right? So are we in the end achieving that figure or not. Let's say we are achieving by 70%. Slowly we are improving that. So that is kind of metrics which shows the progress, right? And it helps in improving the things. So these evaluation metrics are use metrics appropriate for the problem, for example accuracy, precision, recall, for classification, or to access these models. Then we do cross validation. So we use techniques like k-fold cross validation to test the robustness, that is that model is uh, good enough for all the environments or not. For example, if we do web programming, so we create a web page, or let's say web application, mobile application, sorry. So mobile or web, whatever. So we use let's say we use Chrome for our development. But before deploying into the actual uh, servers, so we need to do a lot of cross validation, that okay, my application is very good on Chrome, but is it going to work on Firefox or not? Is it going to work on other Safari browsers or not, or whatever browsers? Because we cannot restrict an application on a particular browser. That day has been gone. Like you may be having Android system, or you may be having iOS system, so it has to be cross validated on all the platforms. Then finally is model deployment and monitoring. So this is how modeling happens. Okay. So these are different models: supervised learning models, unsupervised, and reinforcement learning models. So it is exactly the same thing which we already described. So like supervised use supervised learning techniques, unsupervised use unsupervised. So here in supervised we have data with labels, and the mapping is already there. Here in unsupervised, basically there is input but no mapping, no data is there. So the class is the output. For example, when we say that okay, these are the backbenchers maybe, right? Or these are the less interactive people. So that less interactive is a class that can be further set into abstraction, right? So then reinforcement, which is depending upon agent, action, states, environment, lot of things. Okay. Then we are going to look at some of the classification models. I mean, some of the learning models from supervised learning and unsupervised learning. In supervised, as we know, there are classification models and um, regression models. So some examples are there. In classification model, we have logistic regression, support vector machine, decision trees, random forest, or maybe KNN, or nearest neighbor. So these are the algorithms or models which are used heavily in these days. So for example, this logistic regression, um, this is used to uh, like predicting a customer will default a loan or not, based upon the data it has given. Then we have support vector machine. So that again helps in the biometrics cancer research. So it, based upon the historical data and the mapping it has been given, so it identified the new kind of things. For example, in SVN, so it looks for the cancer malignant cells. If okay, the size has been changed, what is the impact on the body? So these are some different examples here. Like spam filter use that naive bias, and this KNN is used for that association kind of thing, or that Netflix or Spotify's recommendation output. Then we have regression models: linear regression, polynomial regression, gradient boosting regressions or machines. Basically, these are the ones who gives us the numerical outputs. Linear regression is a like straight line kind of thing. It predicts a continuous outcome. And polynomial, where we may be having a dependent or independent variable which is not dependent on the input. It is used when data shows non-linear relationship. So applications here are forecasting stock market trend with the cyclic parameter patterns. Let's say the company is doing very good. It's all the PE ratio and all the other parameters are good, but suddenly there is a pandemic. The you know the requirement for that particular product is not there. So maybe, it is not dependent on the actual data, but okay. Then we have unsupervised learning model, examples. Like in clustering, we have k-means. For example, it group data into the distinct cluster based upon similarities. We have already discussed these, but these are the examples like hierarchical clustering. For example, in customer market segmentation or social media analysis for discovering different communities which are similar in nature. Then we have DB scan. Then there are dimensionally reduction models where we use that PCA or a principal component thing. T distribution used for visualizing high dimensional data in 2D and 3D. Then we have reinforcement learning models. There are basically Q learning and deep Q networks. This deep Q network use deep neural network also, which we are not covering today. So basically, this Q learning is majorly used in robotics and finance, where trading is okay. So now we have come to simulation in machine learning. So we have gone till models. We understood different kind of models, what kind of data is being fed into the models. Now we look at the simulation. So so for working model, we need to give an environment also, right? So simulation is that environment. So simulation is computers based imitation of a real world process or a system which uses the model, right, which represent the key behavior and characteristic of a system. For example, a simulation could be aerocraft, learning simulator, or we have a video game simulator, or we nowadays we have a lot of infra infra based simulators where we have a bat kind of device in our hand and using that I don't know the exact games like Xbox or something. So we use that simulator and we play actual cricket on that. Virtual reality is kind of one of the things. So so these can be actual or the virtual environments. It is used when it is impractical, expensive, or dangerous to experiment with the real systems. For example, I think till date, when we do a course for a pilot, right? So before we actually fly a plane, we work on that aeroplane simulator for I think a few hundred hours. And once we are good with that simulation results, then only I think we used to go to a real plane because it is obviously very expensive. We cannot do experiments on actual models or actual machines. So simulation and machine learning, they are very much related to each other. Simulation in ML is the process of creating synthetic data or modeling real world processes to train, test, or validate machine learning models. Now both can be combined. We need data for both, right? And both generate data. So there are machine learning assisted simulation and there are simulation assisted machine learning. We use machine learning to create a lot of data for simulators, and we use simulators also to create a lot of new data for machine learning because both can generate data, right? So they are very tightly coupled. So machine learning models can be used to refine and optimize simulations. For example, ML model can be trained on historical data to more accurately estimate parameter for a complex simulation, and vice versa. Simulations can generate synthetic data which is valuable for training ML models. So when we talk about synthetic data, so in most of the cases, especially in defense or in this fintech domain where payments or banks or finance related data, so we used to use synthetic data. What synthetic data is, we'll come to that. But just to understand in one line or as in layman language, synthetic data is just a copy of real data where the actual data format or the structure of actual data is copied and it is replaced into the fictitious or artificial data. For example, details of a bank employee or details of a person having savings account in a particular bank account number and other parameters like how much money he has, how many transaction he does, right? Or transaction history. So we get that pattern, and using different simulators or different techniques, we create that data, right? So that when we use that on models or simulators, it does not behave abnormally. The system should take it as a actual data, but it is not the actual data. Okay. Now, how simulation is used in machine this learning. So simulation in machine learning is primarily to generate synthetic data, create virtual training environments, and serve as a testing ground for models. Instead of relying solely on or costly or real world data, simulations allow us for the controlled and cost effective generations of high quality information to train, evaluate, and optimize our machine learning systems. The steps are basically different. Are creating synthetic data sets. Synthetic data sets I already kind of described. Like, it is a real world kind of data which mimics the actual data, but not it is not the actual data, right? Then we have data augmentation. So what data augmentation is basically to generate the actual data. This steps first copies the actual data, and then it replaces the data. For example, you know we we give our images to this chat gpt, and recently there was a thing called Ghibli images, right? Something like that. You give your image to that chat gpt and ask him to create a Ghibli kind of thing. So it copies your data and it mimics the features or properties. It is not your photo, but it looks like your photo. It's not the actual photo. So data augmentation in basically the simulation can augment smaller unbalanced data sets with new synthetic examples. For example, in a computer vision, a model can be trained on limited set of images. Then we copy that image and make infinite images of the similar nature, right? Fine tune them with synthetic data, create in a virtual environment with maybe the texture is different, background are different, lighting effect. I mean, you can do whatever you want to do, right? Then we have what if scenarios. So it can create different kind of scenarios. For example, let's say for a Roomba machine, let's say the floor is uneven, or let's say there are stairs. So what happens if there is a block there, or it fell down? So to mimic the actual world scenarios, we need to create a lot of data which can include what if scenarios also, right? Then we have modeling, testing, and validation. Hybrid intelligence, where the deployed model can be tested with a simulation to evaluate its performance within the real world or larger system. And this virtual test bed help identify the unintended side effects or new bottlenecks created by the ML, right? Because we might have 15 scenarios, 20 scenarios, but maybe machine learning can create hundreds of scenarios which we have not seen. For example, a car, a self-driving car has been uh, being tested, to run on the road when we have a sunny weather or maybe it's a night time. But what about, when there is a fog or there is a rain, right? So we have not tested those scenarios. So maybe, these what if scenarios or hybrid intelligence can give us those scenarios also. Then evaluating hypothetical, scenarios. So that could be anything, right, related to your real world problem. Okay. Then key concepts are data augmentation. We have already discussed. Agent training. Agent training is nothing but simulating it again and again in a control environment through a lot of hit and trials. For example, when I said that when we purchase a Roomba and we place it on a docking station. So what happens at day one, he may or may it it may or may not be able to clean anything at all. It may have hit few walls or some furniture, but eventually with its training or with its hit and trial failures and the past positive results. So one day, maybe after 20 days, he knows exactly the area circumference or the location of each and every furniture types, or the location, so that it can work properly and optimized, right?
Hello, Dipinder sir. Sorry to interrupt you in between. Actually, we have some questions over here, and we
Sure.
are having paucity of time for this next round of session. So, please wind up so that we can have the
Okay.
questions also and move ahead. Thank you so much.
Okay. So I think I'll go with whatever data. So there are some simulation classic examples. I'll share that PPT. Maybe that will be very
Yes,
helpful.
yes, because and definitely I'm listening thoroughly whatever you are saying, because it is very important to know all such when we are going for the model building itself, and we are going for the neural networks or the type of
Right.
analysis, in fact. But it would have been much better if we had done basically we would having the hands-on session also. So
Okay.
go ahead.
No, but I was not aware that hands-on session is also
It's
there.
okay. It's okay.
Right.
Because
No
it
problem.
would have taken
Yes,
few
yes,
more
yes.
sessions for it.
Exactly. We
Yes.
can always conduct some.
Yes. We can always connect with you for that.
Right, definitely. So there are few apps which we can give you a lot of synthetic data, just to wind up, like since the data is the most important factor here. So this is a one of the site called mostly.ai. So here you give us any requirement, so it will give you a lot of data. For example, this data has been generated using some libraries in Python. This pandas is one of the libraries to create the synthetic data. So you can download and you can uh, adjust that. So let me see where that chat is, so that questions can be uh, okay. A lot of questions. While going for model building, when where regression is required, we go ahead with the label data itself for the constructs. So how labeling or unlabeling justified the supervised or unsupervised? Okay. So your question is that where regression is required, we go ahead with the label data itself, right? For the construct. So how labeling or unlabeling justifies super. Okay. So when we are going for the selection of whether we need a labeled data or unlabeled data, the main factor which comes is the domain, right? For example, let me give you one example. In case of healthcare domain, when we work on robotics, right, we cannot go for unsupervised thing, because this is a known domain. We definitely need to know a lot of unknown things, which can be found only by using particular mappings. Let's say a robot is doing heart transplantation, or replacing kidneys, right? So there are some mapped set of things which are already in place. There may be new dimensions to that, new possibilities to that, but it is not that your machine should discover something new and fits your kidney somewhere else, right? Or go for some other areas. So the specific domains where we need a help, that is the main factor, where we choose whether we need supervised learning or unsupervised learning, whether we give need to give that supervised data set or unsupervised data set, labeled or unlabeled data set. Does that answer the question?
Definitely, sir.
Okay.
Sir, we were talking about feature engineering as one of the step after
Yes.
data cleaning.
Right.
So, is feature engineering possible with primary data collection also? For instance, when we are dealing with the customer perceptions, and for example, we are doing the research in retailing and we are dealing with the customer perception. So, we cannot add on the feature engineering when we are collecting the data, because all the constructs and variables are taken beforehand. So,
Okay.
adding the features into it seems impossible, I suppose, or there is some methodology for it.
Okay. So when we say features and when we say variables or data set, These are, two different things. So just treat feature as a function, right? Which will take your variables as input, process it, and gives as an output, right? These are related, but they are not, mutually exclusive to each other. So what is happening? Data is already there. Now, what exactly you want to do with that data? That your feature will, design or depends upon your feature. Let's say, um, let me give you an example where you have some data. Um, okay, you need to select a team, right? For this T20 World Cup or something, you need to select a cricket team, right? Now you have all the parameters available. You let's say you have stats of all the batsmen or bowler or all the players, and based upon those parameters, you have selected those 11 or 16 number, right? And it has been in practice for your many years. Now something happened that a new board came, and that board suddenly decide that, okay, the score is good, no problem, the past history is very nice, but we also need to add the fitness levels, right? So here this new feature will be added, that what is your that fitness, there is a term which is used to call that test, I think yo-yo test or something, right? So we need to add the yo-yo test. So that new feature can be added here.
Yes, so that will depend upon the problem in hand, in fact.
Exactly. And the problem in hand will always change. That is why, every after 3 months, we have a new model of the same phone, especially in Android, or, the iOS keeps on changing. So data may be same, but there might be a new problem, right? Right.
There is one more question by Mr. Kalicharan, that are traditional machine learning models still relevant today, given that modern deep learning models can also learn patterns from data?
Yes. Traditional machine learnings, I mean, these models, like even Tesla car, right? That is also a part of traditional learning model only. So deep learning or the neural network models, they are still um being in the development phase. Right.
So, one more query from Dr. J.J. Mahendra. How do hyperparameters affect model complexity, accuracy, or overfitting?
Okay, I'll give you an example, a layman example, since I know Dr. Mahendra is not from the IT, he's from the chemistry field,
Yes.
right?
He's
So
from
let's
chemistry.
say we have created one website. Let's say example of Amazon.com, right? So we have created Amazon.com, and the and everything is fine, everything is perfect. We have tested that everything is working good. But suddenly what happens during Diwali, or during the Christmas season, suddenly the traffic started getting increasing, because a lot of people wants to purchase things, right? And we have discounts also. So where earlier 1 million people used to visit that website, now millions, like hundred of millions people are visiting. So when we deployed that application, when we put that application on the server, so maybe the cache level is less, the memory is less, the connection pooling is less. Connection pooling is basically how many users can simultaneously work on that. So maybe we have given that stat on the application server, where we have deployed the application is for maybe 10 million users, right? So when we were expecting high traffic volumes, so there are certain parameters not related to the data of the actual website, but to the location where that actual website is hosted, right? So so those parameters which actually help the model, not the problem statement. For example, if this is not clear, then another example, that maybe when we are using that Roomba machine, so the suction power is increased, right, by adding few hyper parameters, or doing some tuning. So that could be another example. So these hyper parameter, they are related to the model itself. They don't have to do anything with the outcome of the model, but yes, they improve that efficiency of that model.
So any other question from the participants? If somebody wants to ask, the person can raise the hand, we can unmute you.
I'll share that PDF and I'll share my details. I mean, if more documentation is required, or
Yes, yes.
through chat or through mail,
Yes,
some
definitely. In
documentation are
fact,
required, I can try to.
kindly share the PPT also, because this is the detailed one that I'm saying,
Yes.
rather than what I received earlier.
Yes. I'll share
Yes.
that. I have added some link also, and I can
Yes.
send some link where you can actually go and use the simulators and generate the synthetic data.
Yes, definitely, sir, definitely.
Right.
Thank you so
For
much.
sure. Thank you, ma'am.
So I would like to extend a heartfelt gratitude to Mr. Dipinder Singh for sharing his valuable insights on such a dynamic and important topic, especially in the context of India's Atmanirbhar mission. His deliberation provides an insightful overview of how machine learning, modeling, and simulation contribute to developing intelligent systems capable of learning, predicting, and adapting to complex environments. It began by defining intelligence as the ability of an agent to perceive its environment, and definitely discussing about the simulation techniques that are widely used in domains like finance or manufacturing, uh, and epidemiology to support decision making. So finally, I feel that the presentation explored data generation through modeling and simulation, and when real world data is limited. So his expertise in this direction and vision are truly inspiring. And I would personally also request Mr. Dipinder to please share with us a video bite about your feedback of this FTP with me or to the coordinator after the session. I also request you to kindly share 3 to 4 MCQs on today's session for conducting the final quiz for the last day. So before I conclude, I would also inform all participants that the feedback form will be available in the chat box or WhatsApp group after the session, please. Thank you so much once again, Dr. Dipinder.
Okay. Thank you so much, ma'am.
Thank you.
Okay. All right. Thank you, guys.
Over to you, Professor Vikram, sir, please.
Thank you, Dipinder, for sharing such an interesting and a very informative session. Now, I would like to invite Professor Harsimran Singh Anand to start the next session, because Pratik sir has already joined this meeting. Over to you, Harsimran sir.
Thank you so much, sir. Good evening, everyone. I am Harsimran Singh Anand, the rapporteur for today's session, and I am joined by Mr. Balram Singh Yadav, our technical coordinator. We warmly welcome you to today's second session of the online faculty development program on AI for Atmanirbhar Bharat, empowering innovation, industry, and inclusive growth. Today's session is indeed very special, as we are honored to have with us Dr. Pratik Bhatia, Associate Professor at the School of Electrical Engineering and Computer Science, Washington State University, USA. We are delighted to welcome back Dr. Pratik Bhatia, who previously served as a faculty member at our institution for 6 years and is now joining us as a resource person. Prior to joining Washington State University, he served as a professor and associate dean of student affairs at Thapar Institute of Engineering and Technology, Patiala. He has also held visiting faculty positions at Whitman College, USA, and the Lambda Lab at Tel Aviv University, Israel. He holds a PhD in computer science from Thapar Institute, a master's degree from BITS Pilani, and completed postdoctoral research at Tel Aviv University. He is a recipient of prestigious Young Faculty Research Fellowship from Ministry of Electronics and Information Technology, Government of India. Mr. Bhatia's research focuses on machine learning, explainable AI, large language models, and AI for social good. He has secured approximately $246,000 in competitive research funding and authored over 100 publications. He is a gold medalist at the UNL Olympiads 2, 3, and 4, and a gold tier NVIDIA Deep Learning Institute campus ambassador. As of June 2025, he has trained 517 students worldwide through NVIDIA workshops. His best-selling textbooks, Machine Learning with Python and Data Mining and Data Warehousing, both published by Cambridge University Press, are widely used by learners and educators alike. He is also the author of popular books such as Simplified Approach to DBMS, Simplified Approach to Visual Basic, Simplified Approach to Oracle, and NoSQL in a Day. Passionate about accessible education, Dr. Bhatia has reached over 45,000 learners globally through MOOCs, Udemy courses, and his YouTube channel Pratik Bhatia Simplifying Computer Education. Please join me in welcoming Dr. Pratik Bhatia, a true pioneer in his field, who will be sharing his insights with us today on the topic, a multi-modal facial cues-based engagement detection system in e-learning context using deep learning. The topic of today's session is of great significance in today's era of digital education. With the rapid growth of online learning, monitoring and maintaining student engagement has become a major challenge. Technology can help educators to personalize teaching, improve learning outcomes, and create more interactive and responsive e-learning environments. Before I invite Dr. Pratik Bhatia to begin the session, I kindly request all participants to post any queries in the chat box along with your name and college. We will have a dedicated question and answer session at the end where all questions will be addressed. Now I request Dr. Pratik Bhatia to please start with today's session. Over to you, sir.
Thank you, Harsimran. Thank you. I hope, am I audible?
Yes, sir.
Okay, good. Thank you. So, just give me a minute. Okay, so thanks for giving me opportunity to present this topic to all of you and discuss on facial analytics and AI tools for student engagement. In this session, our objective is to discuss how we can improve student engagement in our day-to-day teaching by using machine learning and AI. So broadly, this is again going to be a interactive session with a lot of demos, and our objective is to discuss why it's important to have some tools which can help us to check student engagement, or to help us to identify the students at risk. Because when we run our courses, particularly in universities and colleges, there is a huge dropout rate. So how we can minimize that dropout rate? The most important thing is to see who are the students at risk and how we can check their engagement level with ourselves or our courses. In this process, I would be covering these 8 sections step by step with demo so that you can comprehend and apply the things on your own later. So the plan is to start with why it matters, then we start exploring our data sources, data preparations, model building, data interpretations, deployments, and then final thoughts. So let's start our discussion. So it's very important to understand that why it matters to have a system which can help us to detect student engagement and at-risk students. Because all the colleges and universities face serious challenges of having high student dropout rate, especially in the first year. And another important challenge is the low engagement, whether it's online, hybrid, or in even in in-person classes. Students normally suffer with lot less attendance, and they are not too much engaged in our communication or during our classes. So how we can detect that and how we can improve on that? So normally we rely more on our intuitive process, and normally when faculty often realize this too late when student is already struggling. So it is observed that traditional tracking methods are a lot more reactive rather than proactive. So after MST, we try to collect the data, then we try to analyze the things. We took some weeks to, first of all, check our MST exams. And by the end, we have some kind of analysis. Already the time is past, the exams are very nearby, and student already has lost the interest. And they again eventually resulted into dropout. So it's very important how we can use AI to offer predictive insights to identify risk student before failure occur. So this is the overall objective of this talk, and I hope that as an instructor, as a professor, all of you can correlate to that. That yes, it's very important to have timely interventions so that we can support at risk students. And due to with machine learning and AI powered analytics, these things are now become possible. And through this session, we try to cover those points. So again, as I mentioned, if during any point, if you have any questions, feel free to write those comments in the chat box so that we can answer your question in between. And this is going to be an interactive session. I have approximately 1 hour to cover the things with demo. And after that, we will be having a quick informal quiz as we have yesterday. So this is my plan. So let's quickly jump into this topic. So it's very important to first of all comprehend what are the traditional method that we use to uh, check on at-risk student. So normally we all rely on manual monitoring through grades, attendance, participation. But you see that though these methods are normally run by faculty intuition, gut feeling, this is very valuable, but often this is not scalable. So we are looking for a system that can be scalable and that can be a lot more proactive. So often when by the time performance issue is detected, the student is already failing. So our objective is to have some AI or ML system so that we can do those things at quite early stages, and we can take real time insights and can offer interventions without any delay. So data is collected. Normally, we all collect the data in our university, in our colleges, but often these data remain unused or silos in term of detecting high risk students. So the idea is that how we can build a system that can identify high risk student as quickly as possible by using the data that we already have in our system. So there are real case studies from US and all over the world where we can see the impact of having early risk identification system at place. We normally called it as predictive analysis. And you can see that there is a one case study from Georgia State University where they able to identify 800 plus risk students, and with this graduation rate improved by 20%, 22%, and achievement gaps narrowed. And the overall result of that case study is that if we have analytics and timely intervention at place, then it will provide us some measurable success. So our idea of this talk is to give you some insights that how you can apply these skills in your own university or college. I know that most of you are senior faculty member, maybe doing the role of head of department or at administrative positions where you can take the decisions. So the objective of this talk is to give you enough material so that you can propose these kind of solution or implement these kind of solutions in your own college or university. So you see that normally as a faculty, we all identify risk student by using various means. Here I have a question for you to think for a couple of minutes. So you see that normally how we identify at risk student, just think for a minute. So are you relying on the grades after midterm exams, or you use attendance, or you use your personal observations how the things are happening in the class, or sometime you may be going with the multiple practices at the same time. So I hope you most of agree with me that we use all of these three methods. Sometimes we rely on one method more as compared to another, but if we all keep a eye on the grades after the midterm exams performance of the students. Of course, we keep track on attendance, and personal observation is the key. So we always keep on observing on these facts, but still our active participation, you see that there is a time lag in these approaches. And the question is how earlier detection can change the outcome, or how AI or ML can help us so that we can identify at risk student, or in general how we can identify the engagement of our students in our classes, maybe it's online setting, hybrid, or in person. So the most important thing is, since I'm talking about ML and AI, so it's very important to understand the data, what data we have, can we build some kind of ML system on that. So you see that we need some kind of data to build that system. But the good thing is that most of our university as colleges are already having that kind of data. We just need to integrate that data and build some system on that. So most of you will agree with me that we all are maintaining some kind of academic records, which includes their GPA scores or course grade or transcripts. We are maintaining their attendance records. Most of the universities are maintaining that record in the digital form. We are using some kind of LMS like Google Classroom or Canvas or Blackboard or Moodle, which track their logins, time spent, video usage, and forum post and discussions. We use regular assessments like quiz, exams, assignments, and we store that data in our database. We also have demographic data about our students like gender, their socioeconomic background, first generation status, and so on. So the best thing is that we are already collecting the data in some one way or another. But the challenge is that the data is not integrated. So the challenge is not the lack of data, but the challenge is more about lack of data integration and its meaningful use. So in this session, we are going to discuss how we can make best use of this data which we are already capturing, or we can capture very easily by spending little time. And then the most important thing is how we can integrate those things to build a meaningful system so that we can check their engagement level on real time basis. So let's see what kind of data I am talking about. In order to make everyone clear, uh, I'm just giving some examples so that we can all correlate to that, because when we have example, it's very easy to comprehend as a professor to see, oh, we are talking about that kind of data. So let's see what kind of academic record we are already maintaining. You see, we all are maintaining some kind of Excel data or database where we store their student ID, grades, overall percentage of marks or GPA in some kind of data file. So this is academic record, and most of us are already capturing that kind of academic record information by using various software methods. Then the second kind of data is attendance record. Again, most of colleges, universities are using that, and here we normally store total classes, attended classes, and percentage of attendance. So normally we know that if student has less percentage, there is a strong correlation with the poor outcome. But AI can use attendance as a leading indicator to identify at-risk students. So attendance can be another very important data source. If you are using Google Classroom or Canvas or Blackboard or Moodle, uh, like LMS. So these kind of LMS also have some data which they can provide to us about how many login a student have on your Canvas page or Google site, how much time that student spend. If you are putting some videos or presentations, how many videos or presentations the student accessed. So that is called as digital engagement, and it is very intuitive to understand for each one of us that if student has low engagement on in LMS, then most likely the performance will suffer. And AI models can flag these concerns quite early, and it help us to reduce that particular time, and we can easily create that kind of alerts. Next data which I want to share with you is the demographic data, which talk about their gender, age, parental educations, their socioeconomic status, and so on. Normally, you can see that this has a lot of sensitive information, so we must handle that data carefully. And we can build some LMS system also have some kind of metrics which go beyond attendance, like in universities, you may be using some LMS that allows forum post or some kind of reflections, or there may be some place where student can help other students. So these LMS system help us to collect that data in term of how frequently student post something on the forum, or how many times the student is giving feedback to other works like peer review, and how many time it answer the request from other students. So we can also capture that kind of engagement from our LMS. And you can see that if a student has zero participation, then it means that the student is disengaged with all those activities in the class. So here I'm talking about that kind of data. So in the summary, we can see that we already capturing the data, maybe one form or another. The data that I am talking about, their academic performance. Let's go back and see what data we just discussed. So we all are having some kind of academic performance data, which include their grade, courses, and percentage of marks. We already maintaining some kind of attendance data. We are having LMS activity example. If you are using Google Classroom or any LMS system, like how many logins, time spent, video watched, we all collect their demographic data when they join our university or college. That include their gender, age, and so on. And we also have some more data which go beyond the attendance, like as I mentioned about the forum post, how many feedbacks are given, and how many help requests are uh, answered by the students. So these are very important data, and we can create a system which is built on these kind of data, and we can prepare our system, AI and ML system, based on that data. So next section is how we can prepare that data for building machine learning model and performing exploratory data analysis. So now let's jump to data preparation steps. So the point which we are discussing, I just want to give you some more insight, that if some of you are already planning to do PhD or planning to build some system for university, this has enough scope that you can even work on that kind of system for your PhD and other works. So let's see what we have for data preparation and how we can go in that. So data preparation is actually about integrations, combining multiple data sources, as I referred, into one master data set. And we can, when you combine those data sets, most of you are already familiar, or I intuitively can think of, we may need some data cleaning because there may be some duplicate data collected at multiple sources. So we have to remove some duplications. There may be some missing data. For example, sometime we miss the attendance on a particular day. So how we can handle those kind of missing attendance data? Idea is very simple. Just replace that with your class average, and based on that, we can handle that situations. We need to standardized format in one way. Percentage marks can be captured in one different format, and in second table, the you are collecting the data may be in different format. So there may be some multiple formats, so we have to standardize the format during cleaning process. So cleaning is important, and I hope all these 3 points are intuitive and you all can make sense of that. We are talking about when we integrate the system, of course there will be duplications. If the data is missing, it must be replaced with average, and we need to put the data in standardized format. Once we perform the cleaning, the next step is about encoding. So what is encoding? Those who are new to machine learning, I will spend some time on that. You see, all machine learning AI is all about stats, numbers. computer cannot handle non-numeric fields or string. For example, if you're saying that the student is under BCA 1, BCA 2, BCA 3 for or male and female, but computer only understands 0 and 1. So we have to code everything in the form of 0 and 1 to give you a context what I am talking. Let's say we are talking about the gender information. So gender, instead of storing male and female, computer can make better analysis if we just replace that 0 for, let's say, male and 1 for female and so on. Grade, we have a GPA scale or percentage scale, so we have to do that kind of scaling, so that everything must be at the same scale. And we use course type. As I mentioned, the student may be taking math, physics, or CS. So out of 3 courses, the student may be taking only 2 or 3 or maybe all. So in order to store the course name as math, it would make sense to map 0 and 1 to each column. For example, if student is taking CS, I would store the data like in 3 columns, like 0, 0, 1. So 1 under CS mean that student is taking CS. 1 under math mean that student is taking mathematics. So that is called as encoding, because I am able to convert course name into 0 and 1 by using that encoding mechanism, where you can have course name as column, and in the rows you put 0 and 1 if student is taking that course or not. So that is encoding, because it helps us to standardize the scales. It helps us to convert gender or course type into numbers. So we have to perform data encoding during data preparation steps. Then we can perform feature engineering. So in the previous discussion, the Binder is also discussing about feature engineering. So I want to touch more upon that. So you see, sometime we can create our own customized column based on some existing data. Give me an example. For example, you already have the marks of quiz 1, MST, and so on. So you can combine those marks and you can give average score out of all assignments. So instead of having individual assignment score, you can aggregate all the assignment score and give just average of all those assignments. So there is no average assignment score in our database. Our database, or in our day-to-day activity, we are just collecting their marks in 5 different quiz. So instead of using quiz 1, quiz 2, quiz 3, it would make more sense if you add one column average assignment score and just perform the average, or you may able to ignore other columns as such. Similarly, we discussed in our earlier discussion that we can have engagement score. So there is no engagement score as such in our database. We have how many times the student performed the login. So we can create a formula that, okay, number of time the student performed the login, it can help us to calculate some engagement score, and we can have engagement score as a column in our database. Students may submit assignment late. So instead of storing date of submission, we can simply create a column submission delay, how many days the student submit the assignment late, or how many time the student submit late assignment. So that number, 5 times student submit late assignment, or student submit the assignment late by 5 days or 3 days. So that kind of analysis or columns can be added into database, and that is considered as feature engineering. So data preparation mean that cleaning the data, converting the data from non-numeric to numeric, and feature engineering mean that creating new columns based on the task which we are doing, which makes sense to create column for average score, engagement score, and number of days the assignments are delayed, or how many time the student submitted late assignment. Give you an example on feature engineering. You can see here what I am talking about. So we can simply create a column for average assignment score. We can create a column on engagement score, and also we can create a column for submission delay. So these columns we have created by processing the data which we are already having. So they will take some input attributes, and based on that we can create those feature sets, and then it can be mapped to their final results. Let's say that student passed the exam, or let's say that student failed in that exam. So we can map that so that we can build futuristic machine learning model on that. Once we have data cleaned, we can perform exploratory data analysis. What this means, we can so we have data now in tables, but if we can visualize that data through various graphs, it will help us to understand that data better, so that we can understand the pattern or biases before building any modeling. And it helps us to give some common insights. For example, if you have some graph, it's very intuitive to think that, okay, a student has less than 60% of attendance, they may have lower average. Or student who spend greater than 3 hours per week will have some correlation with the high quiz marks performance. Or if student does not, or if student perform timely assignment submission, it can be correlated with the high success rate. So EDA inform feature selection and highlight which variables are more predictive, and it help us to provide visual insights. So normally we create histograms, scatter plots, heat maps, box plot, so that we can see those numbers on visually. So that is the point, and that is considered as EDA. And as I mentioned, this is going to be the next section two, which is about data preparations and building the systems. Section three, which is about data preparations and building the EDA system. If you have any question at this point, someone can read those questions for me so that I can answer that. Because now I am going to shift to demo part so that I can show you side by side how the things actually perform. Any questions if you are having for me?
If anyone has any questions, they can ask right now. We can unmute them, or they can ask their questions in the chat box.
Okay, very good. So now let's see. I have already prepared a full demo file so that I can explain, or you can see everything visually. Soon I will share the QR code so that you can do the experimentation on your own. But let's first see from my side. So here, this is the notebook that will be shared with all of you so that you can quickly apply this in your own college. So the objective is always that you must take some positive outcome whatever you are learning, because each one time is very important. So if you are listening to me, just please focus a little bit more, because here I'm going to share the code so that you can improve on that later according to your own university and college. And my idea is that those who are in decision making process, they must able to understand this clearly so that you can implement those in your colleges and university, because this is what Atmanirbhar Bharat mean. So let's see. The first step is to have data. So in order to give some idea, as Dipinder was discussing my earlier presentation about synthetic data generation, so here I have just generated synthetic data to free from any biases and issue of any identity. So to give you a demo, here we are using some tools which is generating some synthetic data. This particular part of code is going to generate data and set up the environment for this Colab notebook. Colab notebook is actually Google Colab, which don't require any installation or software. You can just run that in your browser. The best thing is that, so that anyone can apply. Maybe if you are not from computer science background, still you can just execute the code by click on this run button, and it will help you to see the outcome and perform those steps side by side. So here you can see that environment is ready. So uh, let me show you the QR code so that you can maybe apply at the same time as I am doing. So you see, the demo is available in the form of a notebook. I request everyone to scan this QR code and don't make any changes in the code, because I'm using that notebook and you are going to share that at the same time. So please scan this QR code. This will take you to Google Colab, and you will able to open that notebook along with me that I am just showing on my screen. So take your time, scan this QR code. It will take you to Google Colab and it will open this notebook file for you. At least take the picture so that I can change the screen. Everyone, please take the picture. I'm going to shift to browser. Okay, so this is the notebook we are talking about. Can you respond? Are you this file? You can use this particular, you can say, chat box, and just write yes if you're able to access it. Okay, I'm also sharing this link on your meeting so that we can make sure that you are doing this with me. So I have shared the link also on the chat. You just need to click and it will open this Google Colab for you people. I want everyone to do this experimentation. So please access that. Anyway, what we were at first step, first is just set up the environment and it will automatically take care about all the installation. So you can see that environment is ready. Just do step by step what I am doing. Don't go ahead. Otherwise, it will complicate the things and you may not able to understand what we are doing exactly. So the first step is generate realistic synthetic data. So here we are generating the data of approximately 10, 1200 students synthetically. And it will have data in the form of attendance, LMS engagement, assessment, demographic, and target. Okay, so I hope now, am I audible now to all of you? Otherwise, I
Yes,
was
sir. Yes,
on
sir.
mute. Yeah. So again, I'm repeating. I think I was mute for some couple of minutes. So what I just discussed with you, that we have this particular point where we can set up our environment variables. Once you set up the environment variable, the second part of the code will help you to generate synthetic data. And this is the second part, and you can see we already have synthetic data, which include, you can see, student ID, gender, age, and all the column which I talk about: logins per week, LMS data, quiz score, total assignment, and their final grade. So we are going to work on that data, but of course this is the synthetic data, but this is very realistic. And then, as I just mentioned, the second part will be data preparation, which include cleaning, encoding, and feature engineering. So here we are removing any duplications, doing some encoding in term of 0 and 1, and then adding columns which are relevant in term of feature engineering. So you can see that after this, my columns are converted to 0 and 1. And you can see here we have added all the columns, and we added a column called as engagement score, as I mentioned, which is calculated as a feature engineering column. We have added a column that how many assignments are late out of total assignment, and submission delay rate, what is the delay rate for that particular student. So these two columns, engagement score and submission delay rate, is actually feature engineering column, and these columns are generated based on what we already have in this data set. So we must combine these feature engineering column with our final outcome, pass and fail. So you see we added that in this particular part of code. So now we have everything at one go, which is a final data set which is ready for building some ML model. So we have normal data which we collected from LMS and various resources, and it also have some feature engineering column like uh, total uh, engagement index and so on. So based on that, we will be building our data set. And once we have the data ready, then we can perform exploratory data analysis, as I just covered in our previous presentation. that it can show us visualization plots so that we can make some sense. So here we are plotting that data by using matplotlib library, and this is what I want to show. So here this is what we have as a distribution attendance rate. So let's put some focus. So you can see that in my class, this is the total number of students and this is the attendance rate. So how many student and where is my overall average attendance distribution in my class. You can see that graphically in this. Here attendance by final grade, we try to combine attendance correlations with the final grade. So you can see here final grade is pass and fail, and it is on y-axis we have attendance rate. Is it possible for you to make some correlation from this graph? So let me make this little bit short. So yeah, attendance by final grade. So you can see that if student has attendance rate average as zero 0.8, then there are high chances for pass, but for fail student, the average attendance rate is less. So this is very intuitive. Those students who are going to fail or already failed in our course, they have less attendance as compared to those who got passed. So uh, this data correlation showing us that yes, there is a correlation between attendance and pass and fail information. Next graph is showing us that how logins mean that when you use Google Classroom or any LMS system, how these logins are associated with their quiz performance. So you can see that this blue circles mean that they are performing good. So you can see we have a lot of circles here, and if student has a lot of logins, you can see here the logins are increased. So if the login are increased, then there are very high chance to get good marks in the quiz. But here below, if you see the student having less logins, then the performance of the quiz is also not that good. So this particular diagram show that yes, there is a correlation between the number of logins they have per week with their quiz performance. And here I have written some notes for you to interpret it clearly. So I have written documentation about interpretation of each and every graph. You can further follow it and read it more deeply that what this mean and what are the important insights from these exploratory data analysis. But what I'm just want to say that we have full notebook for you to understand and apply what we are talking. It's not the theory, it's about the practice. And here, first of all, we are setting the environment. Once we set up the environment, then we are generating some synthetic data which align what we covered earlier, which cover all the columns regarding their attendance and assignments score and so on. Then we perform data preparation, cleaning, encoding, and also we added few columns which are not there in the original database, like engagement score and submission delay rate. Finally, we prepared everything and ready to build our model on that. And that is the time where we can perform some data analysis by plotting some visual graph. So this code is creating three graphs, and you can see that one is distribution of attendance, second is correlation of attendance with final grade, and third is their login performance with the uh, chat box, their overall performance in the quiz. So I'm going to stop my demo at this stage because again I will cover that first with presentation and then I will come back again here to give more insights on that. But if you have any question for me at this stage, you can unmute or you can ask the question on the chat, and someone will read this for me and then we can answer that. Yeah, please. It's very important to be interactive because there is otherwise no fun of just sending the information only on one way. So if I know that once you have some new idea, there must be some questions in your mind, then only you are going to apply these skills or apply these new learning in your own setup. Otherwise, I know that no one is going to do that. So that's why it's very important. If you have any question at this stage, just please ask and don't carry that confusion with you. So I strongly encourage you to ask the question, and if you can unmute, that is also fine with me. So I will wait for your questions. or you can type your question in the chat at least.
Sir, I have one question.
Yeah, please.
So we basically in a college, we are basically faculty members from different departments, and some are basically very efficient as at using computers, and some are not. So what kind of training do faculty members need to make the best use of these AI tools?
Yeah, so very good question. So here, what I'm just try to make my point that we just need to first of all aware as a head of department, maybe from chemistry or physics or any non-CS stream, that yes, there is a possibility of building these kind of systems which require minimum effort. So if you collect the data and provide that data to some students who can take this as a project, even to the CS department who can build that kind of system. So first of all, you must need to you can see understand and appreciate the importance of having that kind of system. So if as a non-CS background system, at least you able to understand what we are doing, why we are doing, and you able to appreciate the value in that process, that's thing I think I is very important. And everyone, maybe from whatever background it is, must able to understand and appreciate and able to comprehend the idea conceptually. I'm not expecting them to implement that their own, but you must have some basic intuitive idea, then only you will back up that idea. Otherwise no one is going to back up that in their own department. So my overall idea for this presentation is to give you enough idea so that you can back up and understand this concept fully, so that you can later implement this in your own institute setting. So, okay, so let's move to
There are
the
some
next
questions.
part.
There are
Yeah,
some
if you
questions.
have any one question, I can take
There are
one
some
more question.
questions. One question is from Dr. Jashandeep Kaur. Is there any way to convert the data from ordinal scale to interval scale?
Yeah, of course, we can convert that kind of data, and we have a lot of Python library which can automatically do that. So yeah, it's possible to convert the data which you have from one scale to another, and we have Python libraries which can easily do that. Yes, it is possible.
And one more question
Okay.
is, can we convert one type of data to other using these libraries, or these just facilitates plotting of data?
No, no. So we have a lot of data cleaning and data pre-processing libraries which can convert, as I mentioned, string data to numeric data 0 and 1. So yeah, it is possible to do that kind of stuff. And we have a lot of Python libraries which can do it very quickly and easily.
There is another
Okay,
question
so
from,
once
there are one or two more questions. One more question from Shivam Mani. Say, how to opt for a feature column?
So thank you, Harsimran. We can take other questions later, but I will
Okay.
answer that question. So
Okay.
yes, we have to think intuitively first of all what feature column we need, and then we have in Python required libraries which help us to create feature columns, and we can have those feature columns based on our problem statement, and we can do that in our practice. Okay, so we have now data preparation, we perform cleaning, we have feature engineering, and the code is shared with you. You can play with that later. And then the next part is model building. So once you have all the data available, next task is to have machine learning model where we can make some kind of predictions. So when we have to make prediction, here this is very important concept, and I want everyone to understand this clearly. So when we have to apply machine learning model, there are two major learning techniques that we can build. First of all, building any AI model, we require data set. So we already have data. We already prepared it. And you can see the last column was pass and fail. And we also have the percentage of marks or GPA. Now, at this stage, we can build two kind of models with our machine learning or AI. One is classification model and second is regression model. And you have to decide in the first step where you want to go. So classification model can only predict one out of three or four option or one out of n option. For example, you want to predict that whether this student is going to pass or fail. That is the case of classification. or whether this student is going to get A grade, B grade, or C grade. This is a case of classification. But if you want to predict how many percentage of marks that student is going to score, that is a case of regression. If you want to predict what would be the GP of that student, 3.5, 4, or 3.9, so that is a continuous number, then it is a regression. So final conclusion, if you are predicting 1 out of n, if you are predicting 1 out of n possible outcome, then this is a classification. But if you are predicting a continuous number, then this is a case of regression. I want to explain that with another example. Let's say we are going to have a match between India and Australia. And if you wish to predict whether India is going to win or Australia is going to win, then that is a case of classification, because you are going to predict win or loss. And similarly, if you want to predict the score of India, then this is a case of regression. So predicting a score is regression, but predicting win or loss is a case of classification. सबके लिए क्वेश्चन है, मैं आपका चैट बॉक्स देखूंगा, and I want everyone to answer this on the chat box. If I have to predict कि whether there would be a rain tomorrow or not, is it a classification or regression? कल बारिश होगी या नहीं होगी, ये predict करना है, ये classification होगी या regression? I want each one of your response. Please type something. Yes, this is a classification because we are predicting one out of two options. लेकिन अगर मुझे ये predict करना है कि कल temperature कितना होगा, 20, 25, 35, 40, then predicting temperature, this is a regression. So prediction of temperature is regression, while predicting rain is a case of classification. So in this case, we have to think what we are building. So if you are predicting pass or fail, that would be reclassification. If you are just predicting their final score or GPA, then it's a regression. And for every technique, there are different models. So here we are just going to predict pass or fail. So I'm going to build classification model, and it will help us to flag those students early so that we can intervene. And every model will have some kind of accuracy and interpretability. So let's jump into that. So if you want to build a classification model, we have various classifiers. One is the logistic regression. It is simply model which can predict 0 and 1, which is very simple model, and I'm going to implement that. We have some more complex model, which is random forest, which also can build classification. Normally, complex model has better accuracy as compared to simple models. But the problem of complex model is that they are difficult to understand their outcome. So when you apply deep learning, if you have very large data set, so the accuracy would be quite high, but it is difficult to interpret their outcome. So always compare the model with valid accuracy metrics. So it's very important. But at this stage, I just want to say that we are going to build classification. We have two models, simple and complex. Simple model is easy to interpret. Easy to interpret means easy to understand their outcome, but normally their accuracy is less. If you go with complex model, their accuracy will be high, but they will be tough to interpret. So in order to demo that, I will go with one simple model, that is logistic regression, and I will go with one complex model, that is random forest. And if you have a lot of models data, you can go with deep learning, but always make a point that you must compare the outcome on the basis of their quality metrics. So when we build the model, we split the data between training and testing. Like agar aapke paas you have a question bank and you want to test the student performance, so you always want to have some training and testing data, or and then you will test the data on testing records. And once you have the data, then model, then we will check accuracy, how many predictions are accurate. We have precision and we have recall. So let's discuss that quickly. Now, what is precision? Precision means that our system is going to flag at-risk students. So we are making some prediction that this student is going to be at risk. So actually that student is at risk or not, that is answered by precision. So my system has flagged that student as risk. Now, actually, what is the state of that student? Is it actually at risk or not? How truly they are, that is captured by precision. Now let's see recall. So let's say we have 100 students at risk. So out of those all 100 students that are at risk, how many are correctly flagged by my system? That is considered as recall. So if you, let's say, have 50 students who are at risk, is my system able to capture all the at-risk student, or it has missed a few students, making flag high-risk students? So that is considered as recall. So flag precision mean that you are saying this is at risk. Actually, it is at risk or not. This is precision. Recall mean that you have 20 at-risk student. Actually, you able to capture all these at-risk students or not, or flag those high-risk students successfully or not. That is captured by recall. I have question for you again. I would wait for your response on chat box. What do you think? What is most important in our case, precision or recall, particularly for this system? We are flagging high-risk student. One is precision, mean that you are flagging, but actually this is not at risk. Is it that significant error? You are saying that this student is at high risk, but it is not that high risk student. You identified it wrongly. Other cases, there are 100 at risk student. You identify all 100, or you can miss few. So that is recall. So what do you think? What is most important in our case? So we are getting mixed response. Some are saying precision, some are saying recall. Okay, it's recall which is more important in this case, not precision. What it mean? Let's say you are detecting a case of, let's say we have a tumor and you want to detect whether that tumor is cancerous or not cancerous. अब आपने गलत रेड फ्लैग दे दिया कि ये कैंसरस है. वो गलत रेड फ्लैग देने का कोई इतना नुकसान नहीं है. वो नॉन कैंसरस था, आपने कैंसरस कह दिया. वो कुछ और टेस्ट होंगे, पता चलेगा कि वो ठीक है. लेकिन अगर वो कैंसरस था और आपने उसको मिस कर दिया, तो वो प्रॉब्लम है. आपने वो कैंसरस था, लेकिन आपने रिपोर्ट में बोल दिया कोई प्रॉब्लम नहीं है, बट दैट इज वेरी रिस्की केस. सो सिमिलरली, स्टूडेंट एट रिस्क में था, लेकिन हमने उसको बोल दिया कि नहीं, ये एट रिस्क में नहीं है, तो ये प्रॉब्लम है. अगर आपने किसी गलत स्टूडेंट को हाई रिस्क बोल भी दिया है तो उसका कोई नुकसान नहीं है. So it will not have that kind of problem if you identify any students which is not high risk student. So my point is that if you have someone which is at risk and you miss that, that would be a problem. If you identify non-risk student as a risk student, that is not going to be a big problem, because ultimately you are going to take more care about that. So we have F1 score which took the balance, but here you see that high recall is critical because we don't want to miss struggling student, and we want that all of these students must be identified clearly. So we will be building the models, we will be calculating our precision and recall, and we will be seeing how many records are actually corrected when we built that kind of system. So we must evaluate our model performance, and then once you get the model, you must able to interpret that. So interpretations mean that understanding what our model is saying to us. So when you get output, let's say your model is saying that this particular student is at high risk, so you must have system that can give the reason why that student is at high risk. So that is considered as interpretability. So normally if you have complex model, then there are tough to make those interpretations. So we want our predictions as a transparent. We want to understand why student is struggling, so that we can perform, we can give constructive feedback. So instead of just labeling high risk, we want more information so that we can understand why that student is struggling, so that you can give some constructive feedback on that. So for this, we normally use some feature importance. So we can say that, okay, you are struggling because maybe there is a problem of attendance, maybe there is a issue of engagement, there may be a issue of quiz average time or submission delay. So we have to provide that kind of feature importance so that we can take appropriate actions based on the flagged student. So normally our system can give that kind of outcome, that student is predicted to fail because he missed 2 assignment, because he have below quiz average score, and low LMS activity. Then only you can take some actionable action instead of just labeling that student as going to fail. So my point is that we don't just want to label the student, we also want their detailed reasoning behind that, and why that student is going to fail, so that you can take appropriate actions based on those insights. And for this, we have some explainability tool that can provide that kind of informations, so that we can move from prediction to action. So it's not only the purpose to make label the students. The purpose is actually to take appropriate interventions, and you can now take possible actions. Like you can say that, okay, if the student has low engagement, then you can take appropriate action. Let's say faculty advisor, to alert about those students, you can suggest some tutoring session after the college. You can recommend some time management training. You can encourage peer monitoring. So you can take appropriate action based on those outcome, that why that student is struggling. So if you know that, you can take actionable actions. It try to understand that our objective of the whole system is not just to make labels, but also to support our decision, so that head of department or administrator can make better decision, or instructor can take better decision about their high risk student, not just labeling those student at high risk. So how we can create those predictions? Let's go back and see the demo about this particular section. So we were here. So we now it is the time to build the model. We already perform exploratory data analysis. So as I mentioned here, we are going to build two models: logistic regression, which is a more simple model, and random forest, which is more complex model. Random forest has better accuracy as compared to logistic regression. And then we are checking their outcome in terms of precision, recall, and we are seeing various graphs. So you see that this is the outcome of random forest, this is the outcome of logistic regression, and then we can compare their outcome in terms of false positive and false negative. So this is their confusion matrix. So you can see that the overall accuracy, yes, see. So this is the outcome which I want to show. So you see, logistic regression has 63%, random forest has 73%. I already told you we are more looking for recall. So here in logistic regression, we have high precision but low recall. Here you see this is reverse. It has high precision but sorry, low precision but high recall. So this is what we are majorly looking at. And if you see the overall F1 score, which consider both precision and recall, so random forest is better as compared to logistic regression. So normally we build multiple model, we compare their accuracy, and we pick then appropriate model. So after this, we will go with random forest, and then we after picking random forest, then we see what are the features that were important. Why my model is saying that this student is at risk. So we can extract important features. So you see that here for random forest, the top important feature are these. So take a time to comprehend this on your own. So can you understand this graph? So this graph is saying that the student performance is mostly affected by quiz, their attendance performance, their engagement with my LMS, how much time the students submit. This is the importance of submission delay rate, their age. So as you go downward, the gender is not that important. Their parental education level is not that important. How many total assignment that student done, maybe not that important, but these are the things which are more important. And this is the feature importance. And I hope you can easily comprehend what this means. Then we can also go and build some more explanations about our outcome. So this is the model which say that uh, gender male or gender female is not that important because all the values are very close to zero. If you see the values are touching 1 or -1, then it means that it is more important as compared to simple if they are more centered towards zero. So we can generate that kind of specific graph by using this kind of models. Then we can also check the fairness, that is my model is suffering from any kind of bias, how my model is evaluating my let's say boys and girls. So you can see that for male, what is the value of accuracy, and for female, what is the value of accuracy, what is the precision and recall for my male students, what is the precision and recall for female students. So if you see there lot more shift in one of the particular gender, then you can see that the model is more accurate for boys, it is not that accurate for females. So that kind of analysis we can also perform by using this kind of data set, so that we make sure that our model must not be any biased. So this kind of model we have, and we can do that kind of analysis by using building the model, and then we can have some kind of data analysis. Particularly, I want to make clear that we can have feature importance, and through this you can see what columns are important and what are not. So what we have at this point, we just discussed that we can create the models which are simple, easy to understand, and you can take appropriate actions based on that data. But what we have shown so far is all about notebook, which is very tough for those who are not from CS background. So is it possible that we can see this system visually without running it? So it means that deployment and practical use. So can we build some kind of dashboard? Can we build a user-friendly interface so that non-technical staff can interact with that? So that is also possible, and that is the best thing that I'm going to give you at this point, that we can convert this kind of notebook to dashboard nowadays very easily and in a simplified way, so that you can see who are your high risk student by having some visual interface, and you can quickly predict and give some real kind alerts. So let's see how we can create dashboard from our notebook. So this is the last part of my notebook, where we are going to deploy the model, and it is going to make some predictions for one of the students. So we give one instance, and for this particular instance, it is saying that this student is going to be high risk, and he's going to fail due to these reasons. So we can even build and save the model. So here we are building the models, and then I'm creating a dashboard for that. So this code will help us to build the dashboard, and then it will generate full API code for us so that we can access this on some browser. So let me run everything in a one go. So it will take some time to run and build the whole system. So if you have any questions for me at this point, you can ask on the chat box so that we can answer it. So the idea of this overall discussion is that you can see it's easy to build that kind of system and deploy that system, so that as an administrator, you can make use of these systems easily. So finally, you can see this is the outcome that you are going to access in the end. So this is the system, that is AI Learning Analytical Dashboard. That is the outcome. And here you see that it give you good idea how many unique student is we have, what is their average quiz score, and this is their engagement over time. So we were talking about the major objective of this talk is to check the engagement. So this is the final outcome that we have. So this is the engagement, that in week 4 we have less engagement as compared to other weeks. So you can see all the graph, and you can modify your teaching practice accordingly. You can see quiz score distribution through a final website, total students by time spent, so how many students spend the time on our course. And this is most important, this flag uh, for student as a high risk student, and you can reach out to these students And this particular software now can provide these kind of details as quickly as possible. So you see, we have this application running live on this particular platform. And let me share this on your chat box. You can also try this at the same time with me. So this is the link, and yeah, you see, this is what I want to show you in the end. So this is live now on the portal, and we able to implement that. You see, this is the demo data, and this is their overall average time, quiz distribution, the total top students, and at-risk students. So these are at-risk student at this time. You can download those at-risk student. The best thing is that you can also upload your own CSV file. So here we have a tab for browse file. Let's update this data. You can update your own data, and based on that, it will change the values and graph. So you see here now it has loaded 320 rows from the data set, and you see the graph now changed. So now the average quiz score is this, and based on my uploaded file, this is the quiz score. And you can see this is the now the total time spent, and these are at risk student based on this particular CSV file. So you can play with this. You can upload any CSV file, and it will show you the outcome based on this particular given data. So let's go back, open, and it will change the data based on my new upload. Yeah, you can see now the average quiz score is changed to 74. This is the data, and this is their quiz distribution, and now these are new at-risk student. So you can set your rate accordingly. So what do you think, what would be the minimum average score threshold value? So you can increase or decrease the threshold value. If you say minimum average score must be 80 in order to ask or look for at-risk students. So if you change the values, you see number of at-risk student increase. So if I increase the threshold value to 80, the at-risk student are now 29. If you say 50% is okay for me, then you will find that the number of at-risk student now reduces. So you can play with that. You can set your threshold value, and you can see what are the flags you require. And if you go back on this code file, I have also given you some sample data to try on the dashboard. You can download the CSV file, and you can upload those. So you see, this is the code which you can directly fine tune for your own university or college, and it will create a public URL for dashboard. So this is the public URL, and everyone can access it. I hope you can access this now, even on your machine, and by clicking on that link, and you can see how the things are going on. Any questions? We have 10 minutes. So I just want to conclude this session before. This is what I want to discuss. So if you have any questions, please type those in your chat box. Okay, so I will take another 2-3 minutes to discuss few important points, and then we will have our quiz as we had yesterday. So ultimately, the overall purpose is to have some kind of dashboard where you can identify high risk student, and I already demonstrated that to you. So once you understand and get those at risk student, then you can build a system so that faculty can get automatic notification on their phone, or student advisor can get information that this student is at risk because due to low activity, and then you can take appropriate actions based on that. So it's very important who can be benefit from that kind of system. So all the faculty members, advisors, students can be benefited if we have that system at place in our universities and colleges. So it's very important that the system must be free from any biases. And most important thing I want to send to you is that it must be, this system must use as a assistive system, not as a punitive system. student must not get a feeling that they are policed. They must get a feeling that they are actually this system is actually helpful for them. For example, if you identify few students at risk, then you must not communicate with them like this: you are failing, flagged by the system. This is the wrong way to use that system. The best way is that we notice your lower engagement. Would you like support resources? So the narrative must always be positive and growth oriented. Then only this system will work best, so that student feel that their analytical is actually not about policing. It's about their assistive model, where you can identify those students and then you can engage with them in a positive and growth oriented way. So the overall objective is that we already are collecting the data. So if we can build a AI system over that, we can easily have early warning systems. And with AI and human AI collaborations, we can build a smaller, smarter AI intervention. So that's our goal. So with this talk, I think that you can start thinking in that direction. You can start with one small department. You can start collecting the data. You can play with this code and build some system and have all the system at place, so that you must use this system as a positive and growth oriented system. So with this, uh, I want to leave you with some positive takeaway, and it would be nice if you can build that kind of things at your institutes or colleges, so that we can build Atmanirbhar Bharat. Okay. We have now 5 minutes. So let's see. I have prepared a informal quiz. Now it's time to have fastest finger first. So it would be nice if you can join this quiz before winding up. You can scan this QR code, or you can open this website. In the meanwhile, you can keep on posting. So you have a question how much it is used in colleges and universities. So yeah, the overall purpose now we have to move in that direction when we talk about AI and building analytical systems. So a lot of system have these things inbuilt at place, but yeah, we can build a system on that, and that is can be a good project for the students. Or if you have system analyst programmer in your universities, you can start experimenting on this kind of system. So most of universities are now having that kind of system at place, even in India. So it's good time to start thinking in those direction and starting implementation. So how many we have right now? 23. So please everyone join. We otherwise there are 161 participants in the Zoom, but we have only 24 active learners. So you see this, I always like that quiz. That give good number about the active learners. That ratio is very sometime important to look into. I know that it is a time to cook food in India. कई लोग किचन में बैठे खाना बना रहे होंगे, तैयारी चल रही होगी. But yes. So let's start our quiz so that we can wind this on time. Okay. So first question. Very good. Let's see the leaderboard. Sakshi is on top. Prab Meher is second. Next. Wow, good. Recall. It ensures we don't miss student. Okay, so last question. Very good. So let's see who are the winners. SM is on number 3. Abhi is on number 2. And who is first? Avi is number 1. Wow, good. So Aishwarya and Harsh are other two top 5. So it would be nice if you can unmute top 3. SM, Abhi, Kavi, can you introduce to all of us? We want to say congratulations to you. SM, we can go with you. Please unmute. Admin can allow those to unmute. Abhi and Kavi.
So those who have got the first 3 positions, kindly raise your hands so that we can unmute you.
Would be nice if you can just introduce before winding up this session.
Kavi, you can unmute you to.
Good evening, this is Dr. Abhijit Das.
Hello, sir.
I'm using the name Abhi.
Yeah, please.
Myself, I'm Kavita. I'm
Yeah,
working.
you are from which place?
I am from Chennai, sir.
Oh, wow, that's good. That's the beauty of this course. Yeah, we have participants. You are from which college?
Mohammed Sadak, AJ College of Engineering.
Oh, wow. Thank you. Thanks for joining and congratulations.
Thank
for
you,
winning.
sir.
Good. Bye. God bless you.
Thank
Next.
you, sir.
Sir Shivam Mani from Amritsar. Sarup Rani Government College.
Which college?
Sarup Rani Government College.
Okay. Thank you. Congratulations. And you are from which department?
Computer Science, sir.
Nice. God bless you. And yeah, third one?
I am at
Yeah,
third
this is
position, sir.
Okay. Yeah,
I'm
second
in
one?
second position. Dr. Abhijit Das from Delhi, Geetaratan International Business School.
Wow, good. Congratulations to all of you. And yeah, so wonderful to have you. And I hope that with this, you able to take it forward and you will implement that in your university. So I have already shared the full code with you. So you can apply that code. And even if you get some issues and challenges in the implementation, so I would be happy to help you. You have my email ID and everything. So yeah, let's build that system and take this forward so that we can help our students in better way by having a real system to identify at-risk student and helping them in a positive and timely manner. Thank you. God bless you. It's all from my side.
Thank you so much, sir. Now we can have the question and answer session. If any of the participants has any query, kindly raise your hand so that we can unmute you, or you can post your questions in the chat box.
So I'm going to share my email ID and my website so that you can reach out to me. I have few queries and also my WhatsApp number. Okay, so these are my details. So please keep in contact and take this forward. So thank you. Thanks to all of you for making this happen.
Any questions? Thank you so much, sir. Now, extending vote of thanks, I would like to express our sincere gratitude to Dr. Prateek Bhatia for the interactive and informative session you conducted. Through this presentation, Dr. Prateek Bhatia has demonstrated that artificial intelligence can transform education by helping teachers identify and support struggling students much earlier than traditional methods allow. Dr. Prateek Bhatia explained that universities already collect huge amounts of data like attendance, grades, LMS activity, and assignments, but this information often stays unused. With AI-powered learning analytics, all these data sources can be integrated to predict which students are at risk of dropping out or underperforming. He shared real examples such as Georgia State University, where predictive analytics improved graduation rates and reduced achievement gaps. The key idea is that AI doesn't replace teachers, it supports them by giving early warnings so interventions like counseling or tutoring can happen before it's too late. Dr. Prateek Bhatia also emphasized that AI models must be transparent, fair, and ethical. Students' data should be used responsibly, ensuring privacy and avoiding bias or surveillance. The goal is to support, not control, helping every learner succeed through data-driven insights. Sir, your valuable insights, real-world examples, and clarity in explanation greatly enriched our understanding and made the session truly impactful. We appreciate the time and effort you dedicated to sharing your expertise with us. Thank you once again, sir, for your contribution and for inspiring us through your talk. Sir, I would like to request you to kindly share a short video bite of your feedback about this FTP with me or with the coordinator after the session. Before we conclude, I would like to inform all participants that feedback form for today's session has been shared in the chat box. It is mandatory to fill it and submit positively by today itself. Now over to Mr. Puneet Sharma, co-coordinator of the FTP.
Thank you, Professor Harsimran Singh Anandji. So as we come to the close of the penultimate day of this enlightening FDP, I extend my heartfelt gratitude to all the resource persons for their active engagement throughout the day's sessions. I sincerely thank Mr. Dipinder Singh Nagi, Associate Director, Fidelity Information Services, Chandigarh, as the resource person of the first session of the day for an excellent explanation of machine learning concepts and the role of data sets, making the topic easy to understand and truly insightful for everyone. My profound appreciations for Dr. Prateek Bhatia, who happens to be the resource persons of our yesterday's second session, and who effectively explained how AI can help to identify students who are at risk and thereby helping the educational institutions reduce, if not eliminate, the students' dropouts, which continues to be a major challenge in the academic sphere. Thanks goes to the rapporteurs of the day, Professor Dr. Rama Bhardwaj and Associate Professor Harsimran Singh Anandji, for meticulously compiling and presenting the key takeaways. Heartfelt thanks to the technical support team, ably led by Professor Balram Singh Yadav, for ensuring the smooth execution of today's sessions. Thank you to all our participants for their enthusiastic engagements. So we look forward to meeting you all tomorrow for 3 core sessions, starting with session 11 on ethical implications of artificial intelligence, and will be engaged by Nagendra Kumar Nekalpu from First Advantage Principal Software from Bangalore, then followed by session 12 on programming in the era of LLMs and will be engaged by Dr. Shri Nivas Swain, Faculty School of Computer and Mathematical Sciences, University of Adelaide, Australia. And the last session, session number 13, will be engaged by Professor Manish Kumar Jindal, Department of Computer Science and Applications, Punjab University, Regional Campus, Shri Muktsar Sahib. So tomorrow we are also looking forward for the validity sessions that is being followed by the test for all the participants. Actually, as for the test is concerned, I got so many queries of text that how it will be conducted. So I want to share you that we have uploaded the questions to the Atal portal, and we have also prepared a Google form of it. So either of the way it can happen. And we got a good number of participant names who want to speak on the reflection sessions, which is being mandatory for the participants of this FDP. So if any other participant who wants to share his views about this FDP, kindly WhatsApp me personally so that we can call their name during the reflection time of the participants. So that's all for the today. See you all tomorrow. Thank you once again.
Thank you, Pratik sir, for such an informative and engaging session. Thanks a lot. It's always good to connect with you, sir.
Thank you. Thank you. Thank you. Thanks, everyone. Thank you. Bye-bye.
One more thing I want to tell you that tomorrow is the last day of this FDP and it will start at 2 p.m. The first session will be at 2 p.m. And the other details, the other schedule will be shared through you people through the WhatsApp group that we have created especially for this purpose. So it's all about for today's session. I request Professor Balram Singh Yadav to stop the meeting.